Great people, welcome to NameTech channel. This is Nehemiah and I'm very happy to have you on board. So this is a full course on machine learning, but we are going to begin from the very basics, like understanding some of the terms used in machine learning, to the very advanced of machine learning, including the practical session, coding and everything. But then before you begin, please take a minute, subscribe, like and share the video to your friends. And to the returning subscribers, I really appreciate you very much for your continuous support. So basically, machine learning is a subfield of artificial intelligence. And traditionally, we use algorithms to produce results from data. So data plus algorithms, we get the results. And then also machine learning creates new algorithm from data and the results. So data plus results, we get the new algorithms, and data plus algorithms, we get the results. And then now we have another term you see in machine learning, is the neural networks, NN. So basically, a neural network is a programming technique, and there is a method used in machine learning, and also is a software that learns from the mistakes. So basically, the neural network are based on how human brain works. So basically, they are responsible for sending messages to each other. And while the neurons are trying to solve a problem over and over again, it strengthens the connection that leads to success and diminishing the connection that leads to to failure. So I'm going to talk about these neural networks in much details, but then let me talk about these perceptrons. Now, basically, perceptrons define the first step into a neural network, and it represents a single neuron with only one input layer, and it has no hidden layers. But then for the neural network, guys, as you can see in this diagram here, it is a multi-layer perceptrons, and it has the input layer which is marked yellow, and then the hidden layer which is marked blue, and then the output layer which is marked red. So in the neural network model, input data that is yellow are processed against the hidden layer which is marked blue to produce an output, a final output which is red. It is marked red. So let me talk about these layers in a few. Let me begin with that yellow part here, the first layer, of which is the yellow perceptrons. Basically, these ones are responsible for making simple decisions based on the input, and each single decision is sent to the perceptrons in the next layer, which is the hidden layer or the blue perceptrons. Now let me talk about these blue perceptrons here, and basically these blue perceptrons in the second layer are responsible for making decision by weighing the results from the first layer, of which is the yellow perceptrons, and this layer makes more complex decision at a more abstract level than the first layer, of which it leads to the final output which is red. Now, let me talk about the deep neural network. Just like the neural network, this one is a programming technique, and there is a method used in machine learning, and there is also a software that learns from the mistakes. So basically, the deep neural network are made up of several hidden layers of a neural network that performs complex operation on massive amounts of data. So each successive layer uses the preceding layer as input. Now, for instance, optical reading uses low layers to identify edges and higher layers to identify the letters. So this is a sample of a deep neural network, and guys, as you can see, we have several layers here. Basically, in this deep neural network model, input data that is yellow are processed against the hidden layer, which is marked blue, and are modified against a more hidden layer green to produce the final output, which is red. So let me talk about this layer. The first layer, just like in the neural networks, these yellow perceptrons are responsible for making simple decision based on the input, and each single decision is sent to the perceptrons in the next layer, which is blue. And then now in this second layer, these are blue perceptrons. These are responsible for making decisions by weighing the results from the first layer. And this layer make more complex decisions at a more abstract level than the first layer. And then this third layer, basically this one makes more complex decisions, which are made up by the these are green perceptrons to produce the final output, which is this red here. So let me talk about the deep learning. And basically the deep learning is a subset of machine learning, and deep learning is responsible for the AI boom of the last years, including the ChatGPT and all that. And deep learning is an advanced type of machine learning that handles complex tasks like image recognition and many more things here. So basically this is the difference between machine learning and deep learning. So basically machine learning is a subset of artificial intelligence, and deep learning is a subset of machine learning. Machine learning uses smaller data set, while the deep learning uses the larger data sets. So and then the machine learning is trained by humans, while the deep learning learns on its own. Then another difference is that machine learning creates simple algorithms, while deep learning makes more complex algorithms. So guys, let's now understand what is artificial intelligence. So basically artificial intelligence is a contrast to human intelligence, and basically artificial intelligence suggests that a machine can mimic human in talking, thinking, learning, planning, understanding. And basically artificial intelligence is also called machine intelligence or computer intelligence. So basically this is the structure of the artificial intelligence, and basically artificial intelligence is a scientific discipline embracing several data science fields, ranging from the narrow artificial intelligence to strong artificial intelligence, including the machine learning, deep learning, big data, and data mining. So guys, let me talk about this narrow AI, artificial intelligence. And basically this narrow artificial intelligence is limited to narrow or a specific area, like most of the AI we have around us today, including the email spam filters, text to speech, speech recognition, self-driving cars, e-payment or electronic payment, and then text autocorrect, automated translation, chatbots, social media, face detection, visual perception, search algorithms, including those available in Netflix and YouTube, then robots, and then we have automated investment, flying drones, and many more others. And then guys, basically the narrow AI is also called the weak AI, and the weak AI is built to simulate human intelligence. And then now the strong AI is built to copy human intelligence. So guys, let me talk about this AI in a few. Strong AI. Basically, strong artificial intelligence is a type of artificial intelligence that mimics human intelligence. So basically, strong AI indicates the ability to think, plan, learn, and communicate. So guys, what you do next, just go to your browser and then type in Anaconda. Just type in Anaconda download, and then find where there's a link to download it, and then let me click here to download it. And then you're going to download for your operating system. Like for Windows, it will just detect the system by default, then it will give you the option to to download it. Remember, for me, I've already downloaded, but then for you are going to download it for your operating system. So it is just straightforward to download it. And then once you have downloaded, then what you do, open it. Now when you open it, you'll have this kind of an interface. We have several programs there, and then I want us to use Jupyter Notebook. and it's very perfect for, especially for machine learning projects. So what you do, just click on it to launch that notebook, that Jupyter notebook. Just launch it, and depending on the speed of your computer, it might take some times, but all in all, give it time to load. So guys, when you launch it, it will direct you to your browser, and you'll have these directories here. So you're going to decide where you want to place your project. But then for me, I can decide to place it here, the desktop, and then here I can create here a new file, and it is Python 3. Just click on it, and then what you do, just give it time to open. Then here it will give you untitled title. So what you do, you can decide to change the name. Perhaps let me call it machine learning, or you can just give it anything, any name. It doesn't matter. Then basically that's how you can rename your project. Or if it fails, try to change the name. Perhaps let me say let me just say ML full course. ML full course, and then I think now we are set to go. So guys, basically the environment is now set for us to begin, but then let me just remind you about machine learning before we begin. So basically machine learning is to make a computer learn from studying data and statistics. So machine learning is a step into the direction of artificial intelligence, as I said earlier. And basically, if you want to focus into artificial intelligence, at least you must have the skills in machine learning. And machine learning is a program that analyzes data and learns to predict the outcomes. So in this course, guys, I will go back to mathematics and study statistics. I will show you that in a few, and then basically we will also learn how to use various Python modules to get the answers we need. Also, we will learn how to make functions that are able to predict the outcome based on what we have learned. So let me talk about the data set in a few. Basically, because we're going to focus mainly in these data sets. So in the mind of a computer, a data set is any collection of data. It can be anything from an array to a complex database. So guys, the other thing, let me talk about the data types. And basically, to analyze data, it is important to know what type of data we are dealing with. And we can split the data type into three main categories. So we have the numerical, categorical, we have the ordinal. Now basically the numerical data are numbers, and that can be split into two numerical categories. You have the discrete data, of which these are the numbers that are limited to integers. And perhaps a good example is the number of car passing by, or the number of people. And then we also have the continuous data, and basically these are the numbers that are infinite, that have infinite values. For example, the values of an item and such stuffs. Then now the categorical data type, of which these are just values that cannot be measured up against each other. For example, a color value, or a yes or no values. And then we also have the ordinal data, of which these are just like the categorical data, but can be measured up against each other. For example, the school grades, where A is better than B, and so on. So guys, basically there are some concepts here that I want us to discuss, basically because they are very essential in machine learning. Like basically I want us to begin by first understanding the mean, median, and mode, of which these are the techniques that are often used in machine learning. So it is important for us to understand the concept behind them. So let's talk about this mean, median, and mode. Guys, basically what can we learn from looking at a group of numbers? So in machine learning and basically in mathematics, there are often three values that interest us. You have mean, of which is the average value. Then at the medium, that is the midpoint value, and then at the mode is the common value, or the number that repeats itself. Like for example, if you have 10 values, or yeah, let's say something like 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, we can just guess that the midpoint can be 50, and then or let me say 10, 20, 30, 40, 40, 50, 60, 70, 80, 90, 100. So 40, it repeated itself twice, so we can say mode there is 40, because it has two values, and so forth. And then at the medium is like 45 or 40 there, or 50. And then now basically so let me guys, we are going to use basically NumPy in this tutorial, and I think guys you've learned I'm assuming that you have learned NumPy before coming to this machine learning course. If you have not learned NumPy, because it is a very fundamental part in this machine learning course, if you have not learned it, I'll put the link in the description so that you may have some clue on NumPy. However, NumPy is a module that has a method for understanding this this mean, mode, and whatever. So let me show you an example, guys, using the NumPy. Let me begin by coding here. So what we do, let me import a NumPy. Import NumPy. You can decide to choose to use NumPy itself, or you can decide to use the alias. Remember, alias is another version, or another name for something. For example, if my name is Nehemiah, and then the alias for Nehemiah, I can say it is NameTech. So NameTech is alias for Nehemiah. So you can decide to give an alias for NumPy, something like basically this is just like a nickname. I can say NP. Basically, NP is a default alias for NumPy. You can choose any. You can just give it even A, B, or whichever thing you like. This is just an alias, but then you must use this keyword AS to define that this one is an alias. And then now here, perhaps let me say a speed. A speed, I can assign it to some a list of values here. Perhaps let me type in 98, 86, let me say 87, let me say 88, let me say 111, let me say 86, and let me say 103, 103, and then also let me say 87, and then let me say 94, or let me say 78. You can use any values, guys. And then 77, and then 85, and then notice, let me use something like 86. Let me count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, good. So guys, basically to find the mean, we are going to use this method here. So first of all, let's define this variable here. Let me define a variable here. Perhaps let me give it x. You can give it any variable name. And then let me use NP. Remember, it is NumPy. NP is the alias for NumPy. And then now we're gonna say mean. And then now we are gonna pass in this speed. Remember, I said that a mean is the same as the average value. The average value. And then now to the print function, if you want to obtain the mean, we are going to say print. Remember, the print function is used to execute the code at the terminal. So you just say print, and then now we are going to pass in that variable, which is x. Then now when you run these codes, you will find what you will get the mean of this array list here. So basically, that's how you can use NumPy to obtain the mean. And then now for medium, you just change the mean here to medium. Let me just change it to median, right? And then what to do, let me run again, and then again you can see that the medium here is is 87. The medium is the midpoint of this array list. That's the midpoint value of this array list. So guys, the other thing is mode. And basically for mode, remember mode is something that repeats itself several times. Now for mode, you can as well use SciPy. SciPy has a module for this. And if you have not learned about the SciPy, I also have the full course in this channel. I'll add the link in the description when I want to upload this video. So I'll add that link so that you may have access to it and I'll have a clue on SciPy. However, let me show you that. So first of all, here we are going to change to SciPy. Basically, you can decide to use NumPy, but for this one, let me use a SciPy from SciPy. SciPy import stats from SciPy import stats. So stat is a submodule of SciPy. So here we are gonna say, let me delete these stats. Then here I'm gonna change it to stats submodule of SciPy, and then dot mode, and then we are gonna pass in that variable which is speed. Remember, if you define a variable here, you must use the exact name in there. And this when you want to pass in here. So what you do, let's run and see if it will work. Let's run the codes, and then guys, basically you can see the mode, the result here, the mode array is 86. So and then the number of times that it has repeated itself is thrice. Let's try to count and see if it is true. 1, 2, what is 3? So you can see the mode here is 86 and it has repeated itself thrice. So basically that's how you can find the the mode. So we have talked about the mean, medium, and mode. So guys, let me talk about the standard deviation in this machine learning course. And basically, standard deviation is the number that describes how spread out the values are. Like a low standard deviation means that most of the numbers are close to the mean or average value. And basically, a high standard deviation means that the values are spread out, over a wide range. Let me show you that. Let me just show you that. Let me use this other cell. And then first of all, let's import NumPy. We're going to use NumPy. Import NumPy. You can use alias, or I can just use a NumPy. And then here, let me say speed again. Then let me assign it to this list 86, 87, 88, 87. It should be 87, and then what else? 85, 85. What else? Let me use 86. Let me stop there. And then what I do, let's now create a variable for our standard deviation. Let me use x, and then let me assign it to NumPy dot.std for standard deviation, and then we are going to pass in that variable which is speed. Should be speed, and then now to the print function, let's say print. We are printing what? That variable for standard deviation that we created just there, which is x. Then what I do, let me run, and then guys, basically you can see the standard deviation there is 0.9574 and so forth. So basically that's how you can obtain the standard deviation. So guys, basically let me talk about the variance, and variance is another number that indicates how spread out the values are. In fact, if you take the square root of the variance, you get the standard deviation. Now basically on the other way around, if you multiply the standard deviation by itself, you'll get the variance. When you square these values, when you take this value, you multiply by the same values, you get now the variance. So what do we mean? So for example, guys, I just take these values. For example, if you want to find the basically if you want to find the mean, I just take for example these values here. Let me just copy. Let me just copy, then let me paste it here. Just take these values like this, and then what you do, you divide by, if you want to find the mean, you just divide by the total number here, 1 2 3 4 5 6. There are six. And then what you do, you'll get what, you'll get your mean. Now for each value, to find the difference from the mean, you just take so guys, basically if you want to find the difference from the mean, you just multiply, you just add these values. Basically you take the mean here, you just take the mean or the average. Then if you want to get the difference from the mean, you just take, for example, this 86 minus the mean, then you'll get what the difference from the mean. And then if you want to find the square root, you just take what, you just take the difference there from the mean, then I just square, then you'll get what, the square values. Now for variance, this one is the average number of these squared differences. So let me guys show you in coding. Let me first of all delete these ones, and then first of all let's import numpy. But then in other times we will be using numpy as an alias. But then here let me say speed, then I'm gonna assign to this list, and then perhaps let me say 32, let me say 111, let me say 138, and then 28, and then 59. What else? 59, let me say 77, and then I'm just using the random values here, and then 97. Now let's create now the variable for our variance. Let me call it x, and then assign it to this numpy dot var for variance, var, and then speed. We're gonna pass in speed, and then what we do to execute the code at the terminal, we're gonna use the print function, print what, we're gonna print x. We are going to print x. Then now what I do, let me run and see the results. And then guys, basically you can see there's the variance for this basically this array list here. So guys, basically here we use this var method to get to find the variance. Now remember the standard deviation. If you want to obtain the standard deviation, you just square root these values, then you get the the standard deviation. If you want to find the variance from standard deviation, you just square. So opposite actually square rooting, that is to get what, the standard deviation, and then squaring the number is to find what, the variance. And the other thing that I want us to talk about here is the percentiles. Now basically these are the terms used here in machine learning, so it's very important for us to have a clue on it. And basically the percentiles are used in statistics to give you a number that describes the value that a given percent of values are lower than. So let's take an example here, guys. Let's say we have an array of perhaps the ages of all the people that live in a certain street. Perhaps let me say perhaps let me create a variable here so that I may show you, you may relate. Let me assign it, let me say ages, the variable. Then let me assign to this list of values. The first person is perhaps, let me say their age is 5, and the other one is 31, the other one is 43, the other one is 48, and the other person is 50 years, the other one is 41, the other person is 7 years, the other person is 11 years, Then the other person is 15 years, and then the next person is 39 years, and then there's another person which is, she is 80 years, and then also we have basically when you have the list can continue. Let me just show you that, because we are not in a hurry. Let's understand everything. 82. Let me say perhaps 32. Let me say there's a 2 years old person, and then also we have 8 years old, 6 years old, and then 25 years old, and then 36 years old. We can say even 27 years old. We can say 61 years old. We can say that one years old, and so on. So guys, basically when you have such a number, we can ask ourselves what is the 75 percentile. And basically for me, because I had calculated earlier, it can be 43 or younger. So basically that's the percentile. But then the NumPy module has a method for finding the specified percentile. So in that case, guys, let me show you that. So remember, once you have imported this module here, you can use it several times, but then because I'm teaching you, let me just repeat it several times so that you may understand everything. First of all, once again, let's import the module, of which is NumPy, and then we have those values of ages there, and then also let's create the variable for our percentile. Let me use the X once again. Then it's NumPy dot basically we use the percentile method to find the percentiles of this array list, and then here we're gonna say percentiles, ensure that the spelling is correct, the percentile. Then we're gonna pass in the ages variable, and then also the percentile for, we said 75 percentile. Then let's do it, let's print out, let's print what, let's print the X now, and then what we do, let's run and see, and then guys, basically you can see it is 43. And so that's the percentile for 75. Now guys, basically the other one, let's try perhaps to find the 95% of the people who are younger than. So what we do, we are gonna just change here to 90, and then let's run, and then I can see guys, basically it is 61. Now guys, basically this is all about the percentiles. Now the other terms used here in or the other concept used here in machine learning is the data distribution. So guys, basically the other concept that you need to master in this machine learning process is the data distribution. So basically in this course, we've been working with very small amount of data, of which I've just showed you, like for example these ages of people, they are just small amount of data. But then in the real world, we have perhaps many data sets. Data sets which are very big with many values there. Remember, a data set is just like a table. If you have a database of very many values, it can be difficult to gather the data, and at least at an early stage of a project you can handle. But then guys, how do we get the big data sets? So guys, basically we can as well use the NumPy to generate the random values, so that we may work with such kind of values. So guys, perhaps let's create an array containing the 50 random floats between let's say 0 to 5. So in that case, guys, remember we have already imported the module here, but then in this new cell we can decide to import it again for you to understand. Remember, I want you to grasp everything, to understand everything. So let's import NumPy, and then what is let's create a variable here, and then let me assign it to numpy. Let's assign it to numpy.random. Remember, if you haven't learned about the numpy random, I have a full course on this numpy. I'll add the link in the description so that you may go through it and have some clues about numpy random. And then here uniform distribution uniform, and then what you do, let me pass in a float 0 from a range of 0.0 to what to 5, let me say 5.0, and then the number of values, they are going to be 250 random values. And then let's print x so that we may generate those random values. So let me say print x now. Then what you do, let's run. I'm guessing everything is okay, so let me run. And then again, basically you can see we have just generated these random values, and there you can see there are quite many. So to handle them, it can be difficult for us, just like we can handle the real world data. It can be very difficult. So let me talk about the histogram now, guys. Basically, to visualize the data sets, we can draw a histogram with the data we collected, and in this case we'll use the Python module called matplotlib to draw a histogram. Remember, I have a full course on matplotlib. I'll add the link in the description for you to go through it and learn everything about matplotlib. However, in that case, guys, let me just let me import the matplotlib. Remember, when you install an account, it usually comes with all those packages. So I'm just importing with the import keyword, import, and then matplotlib.pyplot. But then as an alias plt. Remember, just type in these are all name. These are matplotlib.pyplot can be hectic, so it's good to use what the alias like a plt. And then here to draw that histogram, you're gonna use plt. Now the alias for matplotlib.pyplot, and then here let me say hist, and then I'm gonna pass in x, and also we're gonna pass in 5, and then now you're gonna change the function from print to the show. Basically, you're gonna use the plt.show function to visualize our our histogram, to the terminal. So in that case, let me just say plt, the alias for matplotlib.pyplot, and then let me say show, and then as a function. And then what to do, let's run, and I guess everything is okay. Matplotlib, yeah. Let's try to visualize it. I'm guessing everything is okay. Yeah, so guys, basically let me zoom out a bit, and basically that's how you can obtain the the histogram. Let's try to explain this histogram. Now guys, basically we use the array from the example. The array here, remember I generated 250 random random what the random floats from 0.0 to 5.0s, and in that case we have drawn a histogram with 5 bars. Now basically the first bar represents how many values are in the array of between 0 to 1. In this case, these are first one between 0 to 1, and then also the second bar represents how many values are between 1 to 2, and so forth. Also 2 to 3, you can see it, these are bar represent that case. So you can go, and that you can see this one is around 52 or so. This one is around 48 between 1 to 2, and then 2 to 3 is around 49 or so. Then 3 to 4 is around 51, and then this one is around 50. So guys, basically you can note that the array values are just random numbers, and I will not show the exact same results on your It cannot be the exact on your computer, because it will generate just random values. So let me talk about now this big data distribution. Like an array containing 250 values is not considered a very big, but now you know how to create a random set of values by changing the parameters. Basically, you can just create the data sets as big as you want. Like you can even create what you can even create 10,000 instead of 250. You can create 10,000, and it will display them using histogram with 100 bars or so. So yeah, let me just show you that, guys. Let me just show you. Like let's use random values of 10,000. Let me use 10,000. Then let me run, and then guys, basically you can see there are very many. You can see it's very many. And then here we're gonna change it to let's say perhaps we want to represent 100 bars. Guys, you can see that's how you can do it. That's how you can plot it. So guys, you can see I'm working with the many data, or a real world data. There are very many. So you need to have a clue on how to handle them. So let me talk about now the normal data distribution. Is a very important concept in machine learning. And guys, basically we have just talked about how to create a completely random array of a given size and between the two given values. So now we want to learn how to create an array where the values are concentrated around given values. So in probability theory, this kind of data distribution is known as the normal data distribution, or the Gaussian data distribution after this person called Carl Friedrich Gauss, who came up with the formula of this data distribution. So let me here, I'm going to change it to normal. I'm going to change it to normal. Let me say normal. Let me say normal. Then what I do, let me run and see. And then I guess basically you can see the results, and then I guess you can see the normal distribution graph is kind of a bell. Basically it is known as the bell curve. So guys, basically we use the array from the numpy.random.normal method with 1000 values. We used 1000 values here. Is it 10,000 or 10,000? 10,000 values to draw a histogram with 100 bars. Basically we specified the mean value to 5. We specified the mean values to 5.0 and the standard deviation to 1.0, meaning that the values should be concentrated around 5.0 and are rarely further away from 1.0. And then guys, basically as you can see from this histogram, most values are between 4 and 6, with a top at the approximately 5. So guys, basically that's how you can handle the normal, or you can use the normal distribution. Now let me talk about the scatter plot. Is also another very fundamental concept in machine learning. And basically a scatter plot is a diagram where each value in a data set is represented by a dot. So guys, basically Matplotlib module has a method for drawing scatter plots. It needs two arrays of the same length, one for the values of the x-axis and the one for the values of the y-axis. Remember we just talked about this Matplotlib in the previous lectures. So I have a full course on Matplotlib. You can go through it and learn more about it. However, let me just first of all let me zoom in a bit so that you can see much better. And then here let me create some values here. Remember, when you define an x-axis, the values of an x-axis should be the same, should be equal to the values of the y-axis. Perhaps let me say 5, 7, let me say 8. Sorry, should be comma 8, and then 7, let me say 2, let me say 17, let me say 2, let me say 9, let me say 4, let me say what? Let me say 11, and then let me say 12, and then let me say 9, and then 6. This is for y. Now for actually for x. Now for y, let me say, perhaps let me assign it to values like remember it must be equal, and is a list also. Let me say 99, 86, and then 87, and then let me say 88, 111, let me say 86 again, 86, and then 103, 103, and then also let me use 87, 87, then let me use 94, 94, and then let me use 78, perhaps 78, and then let me use 78, 77, and then 85. Remember guys, I'm just using the values which are available in our website. And this is an MTech website. You can find everything there. And then 86, 86. So guys, basically the X array represent the age perhaps of a car, of each cars, and then Y represent the speed of each cars. And so guys, I want to show you how to use the scatter method to draw a scatter plot in a diagram. Remember, before that you must always import what the module to handle that, and we are using matplotlib here. Let me just say import. Remember, once you have imported the module here at the top, there's no need to import it here, but then for me I'm repeating myself so that someone can understand everything here. But then let's import matplotlib dot pyplot, but then we are going to use it as an alias plt, and then here at the bottom let's use that function, the scatter function, and then let's say plt dot scatter should be scatter, right? Should be scatter, and then we are going to pass in x, and also we are going to pass in y. Now to visualize, we are going to use the matplotlib function to visualize plt dot show, and then as a function. Then what we do is let's draw that stuff, and then let me zoom out a bit. Then guys, basically this is how you can use the scatter method to draw a scatter plot diagram. So guys, basically the x-axis represents the edges, and the y-axis represents the speed. And guys, basically as we can read here, we can read from these diagrams that basically the two fastest cars are both 2 years old, and the slowest car was 12 years old. As you can see guys, the fastest was 2 years old, the car. And then remember I said that this one is the speed, then this one is the age. Fastest is the newest car, which is 2 years old, and then the slowest was 12 years old. So guys, it seems that the newer car, the faster it drives. So let me talk about now the random data distribution. Now guys, basically in machine learning, the data sets can contain thousands or even millions of values. So you might not have the real world data when you are testing an algorithm. So you might have to use randomly generated values. And so guys, as we have learned in the previous lessons or chapters in this course, basically the NumPy module can help us with that actually to generate those values. So I want us to create two arrays that are both filled with perhaps 1000 random numbers from a normal data distribution. The first array will have perhaps the mean set to perhaps 5.0 with a standard deviation of 1.0. Then the second one, guys, here I'm gonna use here set to, we'll have the mean perhaps set to 10.0 and then the standard deviation to 2. So let me just show you that so that I may not talk much without coding. So first of all, we import. Remember, we are using the single notebook. So when you import this stuff here at the top, there's no need to import it again. But remember, as I said earlier, I'm showing you here so that it can be a good practice for you also always to ensure that you have the modules. Remember, if you don't have these modules, you'll have an error. But ensure that you've imported here at the top. Otherwise, just import it in every cell. Let me say NumPy. We are importing NumPy, and then also let's import the matplotlib. Matplotlib.pyplot is an alias plt, or we can as well use np. NumPy is an alias np, and then here let's create a variable, perhaps the first one. Let it be np, remember alias for NumPy, and then a random dot, we're going to use a normal here, normal distribution, normal should be normal, right? And then we're going to pass in the mean, we're going to set it to 5.0, and then a float, and then the standard deviation, let's give it 1.0, and then random numbers, so they are going to be 1000, and then for y, let's use what, the NumPy array itself, and then let me say random basically random normal distribution, normal, then we're going to pass in the mean. We're going to set it to perhaps, let's say 10.0, and then the standard deviation is going to be 2.0, should be 0.0, and then what is the range of values? They are going to be 1000 random values again. And then to visualize, we are going to use this function called plt. Actually, to plot the scatter, we're going to use plt dot scatter, and then we're going to pass in x and y, x comma y, and then to visualize, we're going to use plt function, plt dot show. Remember, for it to work, you must have the GUI compiler for matplotlib. Otherwise, ensure that you have an account that usually comes with those packages. You will not strain to use them actually to work with it. So what I do, let me run and see if it will work. And then guys, basically let me zoom out a bit for you to see much better. And then this is our plot now. So guys, basically as we can see here, the dots are concentrated around the values, 5 values here, around 5 on the x-axis and 10 on the y-axis. So they are concentrated around here. So we can also see that the spread is wider on the y-axis than on the on the x-axis. So guys, let's talk about the linear regression. And basically the term regression is used when you try to find the relationship between variables. So in machine learning and in statistical modeling, that relationship is used to predict the outcome of the future events. So basically the linear regression uses the relationship between the data points to draw a straight line through all of them. And then this line can be used to predict the future events. Like in machine learning, predicting of the future is very, very important. So how does it work? So guys, basically Python has a method for finding a relationship between data points and to draw a line of linear regression. So we will show you. I'll show you how, guys, basically how to use this method instead of going through the mathematical formula. So I'm gonna show you an example here, guys, and it's gonna be in the x-axis is going to represent the perhaps the age, and that the y-axis is gonna represent the speed, perhaps the speed of cars. So we have perhaps we are gonna register 13 cars they were passing toll booth, and then we are gonna see if the data we collected could be used in the linear regression. So guys, without much ado, let me show you that. Let me zoom in first of all, and then we are using matplotlib itself. So import a matplotlib dot pyplot. Guys, as you see, the importance of learning these modules is very fundamental in machine learning and basically in data science courses. So it's very important to have some knowledge of these modules like matplotlib, scipy, pandas, numpy, and so forth. And so plot, and then is a plt alias plt, and then what else? Let's create a variable here. Then let me assign it to some values here. Let me just what I do, guys, let me just copy these values so that I may not repeat myself. Control plus C is to copy, right? Then what I do, let me just paste it here, and then what I do, guys, remember the function is just the same. I don't know why I forgot to copy everything. Let me just say plt dot scatter to plot our scatter. Then we're gonna pass in x and what and y. Also, I'm gonna to visualize, we're gonna use plt dot show function here, and then is a function. So what you do, let's run and see if it will work. And so basically that's how we drew that plot of ours, that scatter plot. So guys, basically we can as well use, we can import the scipy and draw the line of the linear regression here. So what you do here, we can say what, let me I don't know if you can see, let me try to zoom in. Then here let me say from scipy we are going to import a submodule called stats, and then now to use it you're gonna do at let's pass in what, let's say here let me write this function here. Let me say a slope, also intercept, is that's the spelling for intercept, also r, and also p, and also std underscore r. I'm gonna assign it to stats dot linear regression. Linear is it, or oh no, let me use there's a shorter version, lin, then rg regress. So we can use the shorter version, linear regression, lin regress, and then we're gonna pass in what, x and what, and y, x and y, and then let's use here a function. Let's create a function here, and then this function, let me define it. First of all, define a function. Let me call it perhaps my function or my func, and then let me pass in, let me call it x, and then remember to close with a colon here, sorry. and then let me return what? Let me return slope. Let me return slope times actually asterisk, and then x, and then plus what? Plus the intercept. Remember, the intercept is a variable we used here, intercept. And then what we do, let me also create another variable here at the bottom. Perhaps let me call it my model. Let me create a model now. Let's create a model here, and then let me assign it to a list. Let me call it a list, and then let me call it map. Then we're gonna pass in that variable called my func command. And also we're gonna pass in the variable x, and then so here at the bottom, first of all, let me create some space here at the bottom. So basically, guys, we are creating our first model here, and then so first of all, we are going to use a plt.scatter. Then we're going to plot the x and y. Then also let's add in another function here called plt.plot. Then we're going to pass in what? X and what? X and y. X and actually x, not really x, and also that model that we have just created should be my model. And then what we do, let's run and see if it will work. Let's run. I'm assuming everything is okay. Let me believe everything is okay. And then guys, basically you can see you have just drew that line here. So guys, basically what you need, first of all, you must import what the modules you need. Like in our case, it was matplotlib.pyplots, and also from SciPy we imported the stats. So we can learn about these stats in I'll add the link in the description so that you may learn more about these modules here that we've just used. And then the second thing here is to create what the arrays that represent the values in the x and y axis, and you saw it is here. Then the next thing is to execute a method that returns some important key values of linear regression, and that's why we use slope, intercept, rp, then std_ear, and then we pass it to stats.linRegress, and then the values of x and y. And then now guys, we also created a function that uses the slope and intercept values to return a new value, and this new value represents where the x and the corresponding basically on the y axis, and the corresponding x value will be placed here in this function. And then what we did, we ran each value of the x array through the function, and then this one will result in a new array with the new values for the for the y axis. And then in that case we used my model, and then with these codes here. Now guys, basically to draw the original scatter, it is plt.scatter and then we pass in the values of the x-axis, and then the values of the y-axis. Now to draw the linear regression, we use this plt.plot, then my model, and then this plt.show, that is to display the diagram or to visualize. So you can see I've talked about this R and so forth. Let me talk about this R for relationship. So guys, basically it's important to know how relationship between the values of the x-axis and the values of the y-axis is. So if there are no relationship in the linear regression, basically it cannot be used to predict anything. So this relationship, basically the coefficient of correlationship is called R. That's why we used it there. And then the R value ranges from -1 to 1, where 0 means no relationship, and 1 or and perhaps -1 means that there is a 100% related. They are related 100%. So Python and SciPy module will compute this value for you. All you have to do is to feed it with the x and the y values. So should I let me just show you that, guys. Let me just show you that. Let me remove this extra whatever here. Let me remove this function, or I can as well do it. I can as well make it a comment. To make it a comment, just click on control, then at the backslash. Is it, yeah, forward slash, I think, forward slash, to make it a comment, so it will have no any effect here. And then also here, let me also do it. Let me also make it a comment. And then what I do here, let me use a print function here. Let me say print. Let me say print should be print. And then we're gonna pass in what r, like that. And then what you do, let me run, and then guys, basically you can see the result is negative 0.75 and whatever. And basically this one shows that there is a relationship, not a perfect, but it indicates that we could use linear regression in the future prediction. Now guys, let me now talk about how to predict the future values. So guys, basically now we can use the information we have gathered to predict the future values. So guys, example, let us try to predict the speed of a 10 years old car. Now guys, basically to do that, we need the same a function here that we defined earlier. Let me now do it. Let me to make it to undo the comment, just the same function, the same control, and then plus the forward slash. That's to undo a command. And then what is we need to do it. Let me do it. Let me add in this function here. Let me say here our speed. Let me create a variable called speed, and then let me assign it to the function was my func, right? My func, and then we are gonna pass in a 10-year-old car, actually a 10 years old car. And then here the print function, I'm gonna use what, let me use speed now, the variable speed. Then what we do, let's try to predict let's try to predict the speed. And then I can see, guys, it is 85.5930 and so forth. So guys, basically that's how we can do it. We can predict a speed of that 10 years old car. But guys, let us create an example where linear regression will not be the best method to predict future values. So let's try another example here. So the values, let me change the values here, guys. Perhaps let me change the values here. Let me use other values. Perhaps let me say 89, comma, let me use 43, 43, let me use 36, let me use 95, let me use 10, let me use 66, let me use 34, 38, 38, 20, 26, 29, 29, 48, 48. Then what is 48? Let me add in 64, 64, 6, and then what is 5? And let me add in 36, I think. And then what is let me add in 66, and then what is 72, and perhaps 40. And then also let me change the values here at the bottom for different values. So basically, I just want us to try to create an example where the linear regression will not be the best method to predict the future values, and I will see how to use the best method instead of that linear regression. So let me add in perhaps 21, 46, and then 3, and then 35, and then what is, let me add in 67, and let me add in 95, 53, 72, and then 58, and then 10, and then what is 26, and then 34, what is let me add in 90, and then what is, let me add in 33, let me add in 38, let me add in 38, let me add in what 20, let me add in 56, let me add in 2 perhaps, let me add in 47, let me add in 15, let me add in 15, and then what you do guys, what we do here, let me change everything. Let me remove these stuffs here. Then let me undo this comment here. Let me undo the comment, and then what you do guys, let me run this code, and I think everything is okay. Remember, if you have an error somewhere, it will not work. You can see there's an error somewhere here. Let me find all the input array dimension for the concatenation axis must match exactly, but not along the dimension 1. The array at index 0 has 19, and the array at the index 1 has the size of 20. So guys, remember they must match. You can see so let me see, the index at 0 has 19, the first one has 19, the other one has 20. So perhaps let me try to add in some values here. Let me add in some values here, perhaps. Let me see where I can add so that it may match what I want. 43, that's 6. Let me add in another that's 6 here, and that is 6, and see if it will work. Let me run again. Guys, finally it's working. It's working, right? And then now guys, basically you can see now the basically the result is not that good. These values for the x-axis and the y-axis should result in a very, very bad fit for the linear regression in this case. So guys, basically, and what is the correlationship here for this relationship? Now guys, basically you should get a very low R values in that case. Let's try that. Let's try that. Let me first of all make this one a comment. Let me make this one a comment. Let me also make all of them a comment, and then I don't know if you can see. Let me zoom in. And then here let me say print. Print what? Print the correlationship there, R, and then let me run. And then guys, basically you can see it is very, very low correlationship here. Basically this one indicates that it's a very, very bad relationship. And then this one tells us that this data set is not suitable for the linear regression. So we need to have another method to solve that. And then that's why we have to discuss about the polynomial regression. So guys, basically polynomial regression, just like the linear regression, uses the relationship between the variable x and the y to find the best way to draw a line through the data points. So how does it work? Basically, Python has a method for finding a relationship between data points and to draw a line of polynomial regression. I'll show you guys how to use this method instead of going through the mathematics formula. So guys, I'm going to show you an example in a few, of which we are going to register 18 cars in this way, and then as they were we'll assume that they were passing through a toll booth, perhaps to refill the the fuel and all that. So guys, basically we will have to register the car speeds and also the time of the day the passing occurred. So guys, basically we're gonna have the x-axis to represent the hours of the day, and the y-axis to represent the speed of the car. In that case, guys, let me let me just change the values. Remember, the values must be exactly. So we had an error last time when you used a different value. Let me zoom in a bit. Then let me just use a very simple one. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10, 11. Should be 11, 12, 13, 13, let me say 14, 15, 16, 16, let me shift to 18 perhaps, 18, 19, 21, and perhaps 22, and then what is for the y-axis, remember they must match. Here let me use perhaps 100. This is the what? This the actually the y is gonna represent what is the speed. So this one was at 100 speed, the other one was 90, the other one was perhaps 80 kilometers per hour, the other one was at 60 kilometers per hour, and then the other one was again at 60 kilometers per hour. Then another one was at 55 kilometers per hour, 60 also, another person, another car, and then 65, 70, also 70, let me add in 70 again, then 75, 75, 76, 79 perhaps, 79, and then what is 90, and then what is 99, 99, and then 100. So they must be equal. Let's see if it will work. So let's see if it will work. First of all, let me make everything a comment here. Let me make everything a comment. And then here what I'm gonna do, guys, let me say plt. Let me say plt dot scatter. Then we're gonna pass in x and what and y, and then to visualize we are gonna use the same function here there, plt dot show function. Then what I do, let me, if it will work, guys, I can see it is working. It's working. So you ensure that the values in the x and the y axis they match for it to work, and then you'll get this kind of results. Now guys, basically we need to import the matplotlib here. We need to import, you first of all need to import the matplotlib.pyplot, and then I draw the polynomial regression. So in that case, guys, let me do it. Or what I do, guys, other than confusing you, let me just delete everything here, and then let me create another model here called, let me call it my model. Then let me assign it to np. Remember, this is the alias for numpy. We defined the numpy as an alias. Basically we don't have the numpy here. So first of all, let me remove this and use import here. Let me use a numpy instead, numpy. let me say import numpy is np alias, and then here at the bottom, let me say what, let me use poly one dimension, poly 1d, and then what I'm gonna do, let me pass in np dot polyfit, the polyfit method here. Then we are gonna pass in x, y, and also let me use a 3 there. And then what I do, let me also create another variable for the line. Let me say my line. Then let me assign it to np, the alias for numpy, and then let me say line space like that. Then perhaps let me use a 1, and then 22, and then 100. And then now here, this function to draw the original plot is going to be the same. And then now the other function to draw that line, let me use plt dot plot. Then we're going to plot my line. We're going to plot my line, also my model. Then inside my model is going to be my line. And then what we do, let me run and see if it will work. Guys, basically you can see it is now working very, very. Let me zoom out. Again a bit. Yeah, and then guys, basically you can see it is now working very smoothly. So guys, first of all, ensure that you have imported the module. And in this case, we will use numpy and also matplotlib.pyplot, and then also create an array to represent the values of the x and y axis. And the other thing that you realize there, they must tally, they must match. If it doesn't match, you'll have an error at the terminal. And then also you need to use the methods, the numpy methods that let us make the polynomial model. And that's how we came up with this line of code here. And then specify how the line will display. We start at the position 1. And then at the position 22. Then finally at 100. Now this line is used to draw the original scatter plot. And then this second line now draw the polynomial regression. And then the last function here is used to visualize, our plot, actually our graph. So let me now talk about the R squared. Basically, it is important to know that to know how well relationship between the values of the x and y axis is. If there are no relationship, the polynomial regression cannot be used to predict anything. So basically, the relationship is measured with the value called the R squared. And basically the R value ranges from 0 to 1, just like in the other time that we talked about the other regression there, the linear regression, where 0 means there's no relationship and the 1 means there's a 100% relationship. Now guys, basically Python and the sklearn module will compute this value for you. So all you have to do is to feed it with the x and y arrays. So in that case, guys, we are gonna import this. Instead of matplotlib, we are gonna use what? I'm gonna use let me import let me say from sklearn sklearn.matrix import import r squared, it's called r2 or r squared score, and then now here guys we're gonna change some things here at the bottom so that it may work for us better. So first of all, let me just delete this stuff so that it may not confuse you. Remember, I'm not deleting these arrays here because I don't want to type it again, because it's gonna be there just the same. And then here, let me say what let me create a variable called my model to create the new model, and then here let me assign it to the numpy. Remember, numpy we used it as an alias np, and then we're gonna pass in a poly1d, and then we're gonna pass in np the alias for numpy. Then let me say poly should be polyfit, and then we're gonna pass in x and what, x and y, and also let me use a 3. And then now again we're gonna use here a print function. Let me say print what, we're gonna print r squared or r2, then underscore score, actually underscore, and then a score. Then we're gonna pass in the should be y, and also we're gonna pass in my model, the variable for our model that we just created there. And then now we are gonna pass in what? We are gonna pass in let me pass in x now. And then now what we do, let me run and see if it will work. Let me run and see if it will work. Yeah guys, as you can see, it is 0.92, of which it shows that there is a very very good relationship. Remember I said that 0 shows there is no relationship, then 1 shows that there is a complete relationship. So if it is 0.9, then it means that there is a perfect relationship there. So which means we can use this polynomial regression in the future prediction. So guys, basically how do we predict the future values? So we can use this information we have that we have just gathered here to predict the future values. So for example guys, I want us to try to predict the speed of a car that passes the toll booth at around the time perhaps at 17 in the evening. So actually it should be at 5 in the evening. So to do so guys, we need to do the same. We need to do the same in my model array for the example above. So in that case guys, let's do at least let me remove this last line of code here. Remember, we have already created the model here. It is perfect. So now here we're gonna just create a variable here. It should be speed, right? Speed. Then let me assign it to my model. Then let's say perhaps at 17 hours, that is at 5 in the evening. And then now what I do, let me say speed. Let me say print speed when it is at the 17 hours. So let me say speed. Then let me run. And then guys, basically at 17 in the evening, this car will be running at a speed of 96 kilometers per hour. So it predicts that that car running at in the evening, actually at 5 in the evening, it will be at the speed of it actually at the speed of 96 kilometers per hour. But then guys, let's try also to create an example where polynomial regression will not be the best method to predict the future values. So linear regression, we saw it did predict some values, but it was not perfect for some values. So we tried this polynomial regression, but then it cannot be that perfect to predict other future values. So I want us to try to see if it can predict some some of the future values correctly or not. So guys, I basically want us to try other values for the x and y axis, which will return a very bad fit for the polynomial regression. In that case, guys, let me change some values here. Let me change these values. So the problem with me here is to make sure that to match the values in the x and y axis. I usually have a problem there, but then let's try again. Let me say perhaps it's 9, 40, let me say 43, let me begin this time, 43, 36, and then also 36 again, and then a 95, and then a 10, and then a 66, and then a 34, and then a 38, and then a 20, and then a 26, and then a 29, and then what else, a 48, 48, and then let me use here 64, then let me use 6, then let me use 5, let me use 5 here, and then let me use 36, and let me use 66 here, and then let me use 72, let me use 72, and then what is the last one, let me use 40 perhaps, comma, and then 40. And then now the problems comes here, the y-axis. Let me try my level best to be accurate so that the numbers may tally. Let me say 21. Let me say 46. 46. And then 3 perhaps. And then let me say 35. Let me say 67. And then let me say 95. And then let me say 53 perhaps, 53, and then let me use a 72, let me use a 58, 58, and then let me use a 10, and then let me use a 26, and then let me use 34, 34, then let me use a 90, let me use what else, let me try to use 33 here, let me add in 38, 20, 56, 2, and then 47, 47, and then finally let me use a 15. 15, I think they tally now. They tally, I'm assuming they tally here. And then what is here, what I'm gonna do is let me try to create my model here the way it is. Then perhaps here let me add in another, let me create my line, let me create a variable for my line, then let me say numpy. I'm using a numpy as an alias, so let me use np, and then let me say poly 1d, and then I'm gonna pass in numpy, which is np, then a dot polyfit, and then in the polyfit I'm gonna pass in x, y, and not really. Oh guys, basically I'm repeating myself here. It should be very, it should be a different code here, because we have already created this my model here. So here we're going to use numpy, then we're going to use a line, linspace. Let me use this linspace method, linspace, and then I'm going to pass in. So the first point is going to be 2, and then 95, and then the last one is going to be 100, and then let me remove these stuffs here. Then let me use a plt dot scatter, and then let me pass in x and what, x and y, and then here let me say plt dot sure, remember plt is the alias for matplotlib.pyplot, and then here not really dot show. I remember show is to visualize, but then here to plot the graph, you're going to say plt.plot, and then now you're going to plot my line. You're going to pass in my line. Remember, it's a variable that we defined here, and then also you're going to pass in my model. This the other variable here, and then in this my model, you're going to pass in also my line. You're going to pass in my line, and then to visualize now, we're going to use plt.show now. plt.show is a function, and then what we do, let's try to run. I'm assuming that everything is okay this time. Yeah, guys, this is a very great move. You can see there's no error there that x and y do not match. So guys, basically you can see it doesn't give us the very a bad relationship. So guys, basically if we try to get the r squared value, it will be very low, which will be a very bad relation or a correlation. So in that case, guys, let's try to find it. Let me try to print it out. Let me make it a comment first of all. Let me make it a comment. Remember, the other line of code is our model. We don't have to delete it. The model that we have just created. So let me say print. But I want us to get what? Let me zoom in first of all for you to see. So first of all, I want us to get what? The relationship. Actually, r squared and then underscore score. Then now we're gonna pass in the y. We're gonna pass in y, and also we're gonna pass in my model. And then inside this model, we're gonna pass in what? The x. And then now what I do, let me zoom out a bit and run and see if it will. Let me see the result. And then guys, basically you can see it is 0.009. Very low. Results here. And then this one indicates that there is a very bad relationship, and we cannot use this one to predict our future results. So we need to find a suitable method to predict our future, the future results. So that's why we have to use the multiple regression. So guys, basically multiple regression is just like the linear regression, but with more than one independent value, meaning that we try to predict a value based on two or more variables. First of all, how does this work? So basically in Python, we have a module that will do the work for us. So we start by importing the pandas. Let me in this new line of code, we are going to use here pandas. Remember, I'll add the link in the description for pandas full course. We have a pandas full course in this channel. So first of all, we are going to import the pandas model. Actually, the pandas module should be pandas. I like working with the alias. So pandas, I'm going to use pd for pandas. Then you're going to learn more about pandas. If you are interested, I'll add the link in the description. So guys, basically the pandas module allow us to read the CSV files and return a data frame object. So guys, basically the file is meant, I'm going to add in a file meant for testing purpose only, and I'll add it at the description so that you can download it. Basically a file for testing, a CSV file, or you can just try using your own data, but if you want to see the same output is what I'm gonna use here, ensure that you have a CSV file. Let me open it first of all. Let me open my file Explorer. Then the desktop, I have this file called data.csv, and then remember this is it's called that Jupyter file for machine learning. Basically, this is the file that we are using here. This is the notebook that we are using. Now this is the data.csv. Ensure that you have these files. I'll add it at the description so that you may have access to it. And then what I do, once you have it there, I want us to do it. I want us to let me create a variable here. Let me call it df. and then let me assign it to PD. Remember, PD is the alias for pandas. You can decide to use pandas itself. When you use alias, you must add in the keyword s PD, and then here I'm gonna say what pandas dot read underscore underscore CSV, and then we are gonna pass in what we're gonna pass in data dot csv. You ensure that it is at the same directory with your this notebook location, otherwise it will not work this way. You'll have to import the root directory. Even me, I'm not sure if it will work, but I think it will work. So what you're gonna do is basically to do what, let's make a list of the independent values and call this variable x. So first of all, let's create a variable. Let me call it x. Then let me assign it to should I use a capital? Let me use a x. Let me use a capital X here. Let me call it x. Then df, and then here, sorry, should be a list, a two list here. Then the first one, let me call it weight. Should be what? Should be weight. And then the other one, let me call it volume. And then let me create another variable. Let me call it y for emission. And then let me assign it to df. And then this one is gonna be should be a list. Remember, a list is defined using these squared brackets. Then I'm gonna pass in CO2 carbon dioxide, right? And then basically it is it's common to name the list of independent variable with the upper X, and the list of the dependent values with the lower case Y. So guys, just a good practice. And then guys, also we need to import the linear. Actually, we need to import also from sklearn module. We'll also need to use the linear regression method to create the linear regression object. So basically, this object has a method called fit that takes the independent and dependent values as parameters and feeds the regression object with data that describe the relationship. So first of all, let's import. First of all, guys, let me show you that. Let me just show you that. Let me just say from sklearn module sklearn, and then import linear underscore model. Should be underscore model, linear underscore model, and then here let's create a variable here at the bottom. Here at the bottom, let me create a variable called regression. Then let me assign it to the linear underscore model dot, and that this method linear should be linear regression. Remember, it must be linear regression like this way. Linear regression method is a method, so it must be exact. If you use smaller case, it will be a different method and it will not work. And then here, let me say regre dot fit. Then we are gonna pass in x. It should be capital X, and then y. So guys, basically I want us to predict the CO2 emission, actual carbon dioxide emission of a car where the weight is perhaps 23,000 kg, and that the volume is 1,300 cubic centimeters. So in that case, remember guys, all of this is available in that CSV file. So in this case guys, I'm gonna say predict. Let me say predict. Predict what? Predict CO2. Basically, it's just a variable CO2. Then let me assign it to shall be CO2, right? Sorry. Then let me assign it to regre like this. Then dot predict, and then we're gonna pass in some list in this tuple, and then basically 2 dimension, and then here I'm gonna pass in 2300 and also 1300, the volume in the house, and the mass there, the mass in the volume. And then to the terminal, let me say what? Let me say print. Let me say print what? Let me say print this variable here. Predict CO2. I'm praying that it works. If it will not work, then I will have to get back to our codes, and then let me run and see if it will work. And then guys, finally it's working. So you can see the result there is 107.20. So guys, basically we have predicted that a car with 1.3 liters engine and a weight of 2300 kilograms will release approximately 107 grams of carbon dioxide for every kilometer it drives. So it has finally worked. So let's talk about the coefficient. Now guys, basically the coefficient is a factor that describes the relationship with an unknown variable. So if x is a variable, then 2x is that x 2 times that x 2 times. So x is the unknown variable, and the number 2 is the coefficient. That's why guys, you saw that we used the here capital X, so that it may not interfere with our coefficient here. And so in this case, we can ask for the coefficient value of perhaps weight against carbon dioxide, and the volume against carbon dioxide. Now guys, basically the answer we get tells us what will happen if we increase or decrease one of the independent values. So guys, basically let's try to print out the coefficient values of the regression object. And so let me do it. Let me instead of this prediction, let me use a print. And by the way guys, for you to be able to read this CSV, it must be in the same directory with this Jupyter notebook. This notebook called ML Focus. Like in my case, let me first of all open. It is at the desktop, and guys, as you can see, we have this Jupyter file, and then we have the data.csv. They are in the same directory. Otherwise, you'll have to specify the path where the data.csv is. But a good approach is to add it in the same directory. And then here guys, what I do, let me print regret coefficient coefficients, and then what I do, let me try to run and see if it will work. Name error. So let me see. Name regret is not defined. Oh, that's true, because you can see here it is not regression. Remember, when you define a variable, you must use it exactly the way it is. And then guys, basically you can see it is there is the results. And so guys, basically these results are represent the coefficient values of the weight and the volume. So it means that the weight is 0.0075 0.5095, and the volume is this kind of a value here. So these values tell us that if the weight increased by 1 kilogram, then the carbon dioxide emission will increase by 0.0075595 grams. And if the engine size volume increased by 1 cubic centimeter, then the carbon dioxide emission will increase by 0.0078052 grams. So I think I think that is fair. It's a fair guess, but let's test it. As guys, we have already predicted that if a car with 1900 cubic centimeters engine will weigh, actually weighing 2300 grams, the emission will be approximately 107 grams. So what if we increase the weight to 1000? Let's try that. Let's try to increase the weight to what? To 1000. Let me undo. I think when I undo, I'll get. Yeah, let me try to increase to what? Let me try to increase to what? Let me increase it to some values here. Let me use let me see here, instead of the 23, let me use a 3300. Then what I do, let me run, and then guys, basically you can see the result there. We have predicted that the car with the 1.3, remember there's a 1300 cubic centimeters, the same as 1.3 liter engine. So, and there's the 300 is the mass, which is in kilograms, which will release approximately 115, when you round off, 115 grams of carbon dioxide for every kilometers it drives. So which shows that the coefficient of 0.0755095 is correct, like what we did. So basically, if you want to do that, if you want to calculate, you can just do that 107.280875 plus 1000 into 1000 into actually into 1000 times that, 0.0075595, and then I will basically get these values here. So guys, basically scale features when your data has a different values and even different measurement units, it can be difficult to compare them. So what is kilograms compared to meters, or altitude compared to time perhaps? So the answer to this problem is scaling. So we can scale data into new values that are easier to compare. So guys, basically it can be, I want us to talk about something else. So guys, basically I'm going to show you an example in a few. Basically there are different methods for scaling data in that we can use in this course. First of all, we use a method called standardization, and basically the standardization is the method that uses a formula. Should I type for you? Let me just type in Z, then let me into x minus u. I'm going to explain it in a few, and then over x. And so guys, basically here z is the new value, x is the original value, and then I use the mean, and s is the standard deviation. So if you take the weight column from a data set that you have, then perhaps a value, the first value perhaps be any value, then the scale will be, perhaps let me show you an example. Should I I'm going to show you just a full example here. Let me just show you guys a full example so that you may get everything. Let it be the way it is. Remember, it will render only the cell that is active. So here let me say what, let me add in another method, another module called, let me say from sklearn dot will be pre-processing, right? Inakwanga pre-processing, right? I think pre-processing, and then I import what we're gonna import standard. Standard scalar. And then let me also define a scale too. Let me create a variable for scale. Let me say scale. Let me assign it to this let me assign it to standard. Let me assign it to standard scalar method. So anytime I'll be using a scale, it will be representing standard scalar, standard scalar method whenever I'll be using that as a scale variable. So in that case, guys, here at the bottom, let me remove these other stuffs so that, and then here what is here, let me also remove this one so that we are not discussing that linear regression. Then here let me say scale. Let me say scale scale dx, and dx. Then I'm gonna assign it to scale. Remember, guys, I said that whenever I use scale, remember it's a variable here. When I use scale, it stands for standard scalar method. So here let me say scale dot fit underscore transform x underscore transform x. By the way, let me just remove this y-axis. I don't need it at the moment. Let me just make it a comment. And then what is here? Let me say what? Let me say print. Then in the print function, I'm gonna pass in this variable here. Let me believe everything is okay. I don't want to see errors, so let me run and see if it will work. So guys, basically you can see the results are very, very perfect here. Basically the first two values and negative 2 point these values here and this one, this one corresponds to your calculation if you try to calculate it manually, or basically how we did it earlier. So guys, let's now talk about how to predict the CO2 values. Remember while we were discussing multiple regression earlier, we predicted the CO2 emission from a car when we only knew its weight and the volume. But then when that is set to scale, you will have to use the scale when you predict the values. So in that case, first of all, let me undo this comment here. So guys, here let's say what, let's define our regression here. Let's say perhaps let me call it regret RGR, and then let me assign it to the linear regression. Basically it's a linear model. Let me use a linear model dot linear regression. Is this the spelling for linear regression method? Yeah, I think. And then also let's do it. Let's define. Let's also say regret should be RGR, then a dot fit, then we're gonna pass in what? These are scale dx. Then here I'm gonna pass in that values here, then also the y, and then also let's do it. Let's say scale. Remember, scale is a variable. Is a new variable. Remember, scale. Just scale here stands for standard standard scalar of which we used here, but then our scale is a different variable, and then I'm going to assign it to scale, which is the variable for standard scalar method, and then dot transform then I'm gonna pass inside this tuple. I'm gonna pass in a two-dimensional array here, perhaps 2300 by 1.3 liter, 1.3 liters perhaps. And then what we do, let's say what, let me remove first of all this print function because I don't need it. I don't need at the moment. So let me say predict. Predict what? Predict CO2 should be CO2, and then in this prediction is gonna be, we're gonna pass in that variable regress, and then dot predict, and then we're gonna pass in what, that we're gonna pass in that variable called scaled. Remember, you must be accurate, otherwise when you use a different variable, it will not work. I assure you, it will not work. And then remember, this scale it should be inside a list. And then also the values here, the index for the index number, let's define it 0, the index 0. Then the print function, let's say print. We're going to print what, there's a variable here, predict CO2, carbon dioxide. Then what I do, let me try to run and see if it will work. Yeah, guys, finally it's working. It's working, right? And then the values here is 97.072 and whatever. And so guys, basically that's how you can work with the scale, let's talk about how you can train and test, your models. Let's now discuss how you can train and test the models. So guys, basically in machine learning, you can create models to predict the outcome of certain events, like in the previous, like just in a few, we have just discussed about how to predict the CO2 emission of a car when we knew the weight and the size of the engine. So guys, basically to measure if the model is good enough, we can use the method called test stroke train. Actually, train and the test. So first of all, what is train test? Basically, train test is a method to measure the accuracy of your model. Now, it is called train test because you split the data set into two, a training set and the testing set. So 80% for training, and then the 20% for the testing. So you train the model using the training test, and then you test the model using the testing set. So train the model means you create the model. Then the test the model means to test the accuracy of the model. So guys, I want us to start with the data set. So let's start with the data set you want to test. Now basically our data set illustrates perhaps, let's assume it illustrates 100 customers in a shop, and they are shopping habits. So I'm gonna use just a random value because to type those values is hectic. So let me use numpy random. So first of all, let's import a numpy, but as a random, actually as an alias, not random, as a np alias. And then also let's import matplotlib. Let me say import matplotlib. matplotlib dot pyplot, and then is a PAT alias also. And then what else? Let's import the let me say let me use numpy dot random dot seed and then dot seed 2, and then here guys, what I do, let me create a variable here for the first random. Is gonna be np. Let me just don't use the alias, so that this time let's work with just numpy as it is, so that you may try also to understand every concept here. So let me assign it to numpy, not np again, numpy, and then dot random, and then dot normal, and then we are gonna pass in what 3 1, and then the value is gonna be, let me use 100 random values, and then basically 3 is the what 3 is the mean, then a standard deviation, then what, then the values, the number of values, and then for y, let's assign it to numpy dot random dot normal, and dot normal, then we're gonna pass in 150 is mean, and then 40 standard deviation, and then what is 100 values, and then is gonna be over x, that variable there, and then now to visualize, let's say plt, it should be plt, not really to plot, actually to plot that scatter, plt dot scatter, then we're gonna pass in x and y, and then to visualize now, we are gonna use what, let me say plt dot show is a function. Then let me run and see if it will work. Let me hope it works. Yeah guys, basically you can see it does what it works. So basically remember the results, these are just random values. It can be different from your computer, but then the x-axis represent the number of the minutes before making the purchase, and then the y-axis represent the amount of money spent on the purchase. So guys, I want us to split into the train and the test. So guys, basically the training set should be a random selection of 80% of the original data. Then the testing set should be the remaining 20%. So what I do guys, let me show you how to add those values here. Let me show you guys how to do that. So here at the top, I'm gonna do this. Let me say train what? Remember there are two values here. Let's say train x. Let's begin with x. Let's say train x. We are gonna assign it to x into 80. It's gonna be 80, and then let me just duplicate. Let me copy, and then let me paste it here at the bottom. Then here it should be y, and then here let's again say for testing, let's say test underscore x it should be 20%. It should be, remember here it should be y. If you are not keen, you'll have issues at the terminal. And then here should be x, and then we are passing in what, 20%. Actually should be 80%, right? Sorry. Basically to train should be 80% now for test. should be what? Should be wait a minute. Training should be a random selection of 80%, right? For training. And then now testing should be 20, yeah. So for 20, it's gonna be it's gonna be what? It's gonna be not share should be 20. So for 20, just say 80. Then like that. So 20 of 100 is gonna be 20. And then what I do, let me just split it. Let me just copy again. And then I do it, let me paste it here. Let me paste it here, and then here I'm gonna change it to Y. Also here, let me change it to Y. So we have split into two for training and what for testing. So the display actual to the display, we need to display the same scatter plot with the training set. So in that case, guys, we're gonna do this. We're gonna say what we're gonna pass in. These are variables. We're gonna pass in what? These are variables. So the first one is gonna be this variable train. Let me say train underscore x, also train underscore y, right? Train underscore y. Then let's try to run and see if it will work. Yeah, guys, basically you can see the results the way it looks like. Remember, it can differ because these are just random values. It will vary depending on what your computer generated those random values. So guys, basically to make sure that the testing set is not completely different, we'll take a look at the at the testing set as well. So yeah, I think guys, you can note the display of the train. Let's try test and see if it is the same. Let's say test should be what? Should be test x, and also should be test y, and then let's run again and see if it's, and then I guess I basically can see it is almost the same. So the testing also look like the original data set. So guys, basically what does the data set look like? So in my opinion, I think the best fit will be a polynomial regression. So let us draw a line of a polynomial regression. Now remember, to draw a line through a data points, we use the plot method of the matplotlib module. So in that case, guys, what you're gonna do here, let's do this. Let me create my model here. Let me say my model, then let me assign it to numpy, then at poly 1d, and then I'm gonna pass in numpy. Remember, if you're using an alias, you just type in your alias name instead of numpy. But then let me say polyfit, then inside it I'm gonna pass in what? And that train underscore what? That variable train underscore x, and also train underscore y, and then also we're gonna pass in a 4. Also, let's create for the line a variable. Let me use my line again. Then let me assign it to numpy dot line space. That line space should be line space, right? Should be just a line space like that. And then we're gonna pass in a tuple, then 0 the first index at the first point, 0, then 6, and then the last one should be 100, right? And then what else? Let's also create another one here. Remember, this one is the original plot. Then let's plot the other one for let's be plt.plot. Then we are going to pass in what? My line. my line, and then also we are gonna pass in my my model, and then inside this my model is gonna be my line. Remember, it must tally with the variable that you used there. And then remember the function here is to visualize. Then what I do, let me run and see if it will work. Yeah, finally it's working. And then guys, basically you can see the results are there. Remember, it can be different depending on your random values, but it will look like this way. So guys, basically the result can back my suggestion that the data set fitting polynomial regression, even though it will give us some weird results if we try to predict values outside the data set. For example, the line indicates that here the line indicates that basically it indicates that the customer spending like 6 minutes here, like 6 minutes here is probably a sign of a fitting, right? Kind of. And then but what about the R squared score? The R squared score is a good indicator of how well my data set is fitting the model. So remember guys that the R2 is also known as the R squared. It's a measure. It measures the relationship between the x-axis and the y-axis, and the value ranges from 0 to 1, where 0 means there's no relationship, and the 1 means there's a total. There's a 100% related. So guys, basically this sklearn module has a method called the R2 squared. Guys, we have just used it previously. R2 underscore score method that will help us find the relationship. So in this case, we would like to measure the relationship between the minutes of our customer. Basically, the minutes a customer stays in the shop and how much money they spend. So basically, let me show you guys an example how well does this training here, this data trained fits this polynomial regression. So in that case, guys, let's import what? Let me remove this matplotlib because I'm not going to use it now. Alright, let me make it a comment. Sorry, let me make it a comment, and then here let me use what? Let me use from sklearn dot metrics import what? R2 underscore score. R2 underscore score, and then what we do is let's try to do that. What else should we do here? Let me first of all remove these tabs here at the bottom. Let me use here. Let me delete this one, and also let me delete this one. Let me delete this one. And then here let me use R2, and then let me assign it to this R2 underscore what? Underscore score. And then I'm gonna pass in train and what? Train y, and let me say train y. Let me just type in. Train underscore y. Should be an underscore y, and then also let's say my model, and then I'm gonna pass in what? Let me pass in train x, train underscore x, and then what else? Let's try to what? Let's print that and see if the relationship. Let's say print R2 and see the relationship there. And then guys, let's find the name my mod is not defined. It should be my model, right? I forgot somewhere here. Yeah, here it should be my model, not my model. And then what I do, let me run and see if it will work. Guys, basically you can see the results is, and the result is not good at all. Guys, the result is not that good. So the relationship here is not okay. Don't know what the problem here. Oh, guys, basically let me use a here one. Let me use a one here so that we may get some other results. So I think that's where the problem came from. Let me run again and see if it will work. Yeah, guys, basically it works now. You can see now it's now okay. It shows that the result is 0.799, which means that the relationship is okay. So now we have to made made the model that is okay, at least when it comes to the training the data. So we want to test the model with the testing data as well and see if it will give us the same results. So let's change it to test. Let's change it to what? Let's change it to test. Here, let me change it to test. Test. Also here, let me change it to test and see if it will give us the same results or the related results. Yeah, guys, basically you can see it give us 0.89. We have established that our model is okay. We can start predicting the new values. So let me guys show you an example how to predict our values here. So in that case, guys, let me do that. Let me remove this one. Let me remove this one, and then here let me say print, and then let's do it. Let's pass in what? My model that we just created. Then I'm gonna pass in what? I'm gonna pass in even 5. Then let's run and see. Guys, basically it works. You can see it is 22. So guys, basically the example predicted that the customer to spend $22.88. So guys, let's now talk about the decision tree. And basically remember, decision tree is a flowchart that can help you make a decision based on the previous experience. So guys, I'm gonna show you an example of a person of which he or she will try to will decide if they need to go to to a show or not. So, but in our case, in the data set that we have, a person has registered every time there's a show, perhaps in the town, and registered some information about the comedian or that show, and also registered if he or she went or not. And so, guys, first of all, let's read how does this work? First of all, let's read the data set with pandas. Let's say import what we are going to import. It should be pandas, right? Let's say pandas. We are using pandas for data analysis. And then let's say df. Let's assign it to pandas dot read underscore CSV. Remember, I'm using a CSV. You can as well try with the JSON or whichever file you have, but then it accepts only CSV and the JSON. And then let's pass in what that should be. I'll also add in this. I'll add this file in the description so that you can download and use it. So it is data.csv. Now let's print out and see the values therein. Let's say print, and then we are gonna print in df. And then what we do, let's run and see if it will work. And then guys, basically you can see it is now working very well. So This is how you can do it. This is how you can read and print the the data sets. So guys, basically to make a decision tree, all data has to be numerical. We have to convert the non-numerical columns. Perhaps these are nationality and what else? These are and they go into numerical values. So Pandas has a map method that can make a dictionary with the information on how to convert the values. And so like I can say perhaps UK, here we give it something like 0, USA, we give it 1, and then this N we give it 2, and so forth. So guys, basically let's do that. Guys. Let me say here at the bottom, guys. Let me do that. Let me do it. Let me change some codes here. Let me change here some codes. Perhaps let me add in. Let me say D. Then I assign it to a dictionary. Let me pass in a dictionary. So the first key, let me call it UK. And then in this UK, I'm going to assign it a value of 0. Let me assign it to 0. Then the key for USA, let me assign it of what? Let me assign it a value of perhaps 1. And then what else? For N here, for N, let me use what? Let me use the key should be N, and then the value I'm gonna give it 2, index 2, index 2. Then what is for let me now say DF, and DF. Then I'm gonna pass in a dictionary here. Let me say the first one is nationality, right? Nationality, and then what else? The nationality. Then let me assign it to DF, and then inside I'm gonna pass in nationality. Is a string, remember, so it should be nationality, and then what else? Let me use a now dot map method here. Let me say dot map, so that we may convert it to an integer. Then I'm gonna pass in a tuple here. Let me call it D, and then what else? Here at the bottom, let me say D. Let me add in some arguments here. Perhaps let me add in a dictionary here first of all, and then here let me pass in yes. Let me pass in what? Let me pass in yes. Yes to be what? Yes in capital. Yes. Let me give it what? Let me give it 1, and then and then a comma first of all. Then for no. For no, let me give it what? Let me give it 0, right? Let me give it 0, and then let's also change what? Let's use now the map now to convert it. Let me use small d, df, and then let me pass in what? Let me pass in go. Should be go, and then let me assign it to df, and then df, then go a string. Remember we are specifying these stuffs here. Go, and then let me say dot map. Dot map, and then we are passing d again, and then what else? Let's print now df and see if it will work. I'm hoping it works. So let me run and see if it will work. And so guys, basically, as you can see, we have converted these values to the at what to integers. All of the values now, they are now in integers. So guys, basically then we have to separate the feature columns from the target column. So guys, basically the feature column are the columns that we try to predict from, and then now the target column is the column with the values we try to predict. So guys, let's do this. Let me show you an example, guys. I'm gonna use X as the feature columns, and then Y I'm gonna use it as the Y column. In that case, guys, let me do this. Let me say what? Let me say features. Remember, guys, I've already defined it at the top. Every thing that I need here. So let me just say features. It should be features. Features. Then let me assign it to. And the first one was age. Let me say age. Let me pass in age. It's a string, remember? Age. And then and the second one is experience. Experience. Then the other one is rank, right? The string, so rank. And then the other one is a nationality. It's a string, remember? Nationality, right? And then now let's create the variable. I'll use capital X here. Let me say X. Let me assign it to df now, df. And then here's gonna be features. I'm gonna pass in features. And then for y is gonna be go. Let me say y, small y. Then let me assign it to df. It's gonna be the go column. So basically the target column. And then what I do, let me say print print x is capital X. Then or rather, guys, should I just use the small x? Let me use a capital X. And then what else? Let me use let me say again print. Let me print a y. Then what I do, let me run and see if it will work. And then guys, basically, as you can see, it is working. It's working now. So guys, basically, you can see we have these results here, and basically now we can create the actual decision tree, fit it with our details. Let's start by importing the modules we need. So first of all, remember the goodness with Jupyter. You can, when you use a different cell, to just render that cell that you want to execute. The other cells will remain the way they are. So that's the goodness. That's the goodness with the Jupyter Notebook. So here, first of all, let's import what? Let's import. Remember the modules you have already imported here at the top, but then let me just show you so that you may be sure to have imported. Let me say import. First of all, we're importing pandas. Also, let's import from sklearn import that tree, should be tree, and then tree. Then let me say from again sklearn module. We are gonna import from sklearn.tree. sklearn.tree. We're gonna import what? Decision tree classifier. Decision tree classifier. Classy. a classifier like that. And then also we're going to import to visualize. We're going to use some matplotlib. So import matplotlib dot pyplot. Remember, this module is specific for visualization of our the graphs. And then here we're going to use it as an alias, as a PLT alias. And then let's say df let me say df. Then or rather guys, let me just copy this code so that I may not repeat myself. Here at the top, let me copy these codes here to where? Let me copy to here. Let me copy it to there. And then also here, let me copy these codes. And let me copy these codes here. It's not a good practice to copy, but I feel like I'm tired. Let me just paste it there. And then what I do, let me create a variable here for decision tree. So let me call it d3. Then let me assign it to the decision tree classifier. Decision should be decision tree classifier method. I think this is spelling. And then as a method, so I'll be using this variable instead of the other stuffs. Again, d3 again, I'm gonna use. So let me use a d3. D should be d3. And d3 again, I'm gonna use it. D3. Remember, this d3 stands for data method here, decision tree classifier. And then here I'm gonna say what dot fit, and then we're gonna pass in that capital X variable, and then also Y. So here let me say what tree dot plot. Then we are gonna after tree dot plot, then underscore tree, then we are gonna pass in d3. And d3 also we're gonna pass in feature names. I'm gonna assign it to the features variable. We used it somewhere. Here it is. And let me pass in. Guys, I forgot. Here I should also have copied. These are features here. Let me just copy. And then I do it. Remember, if you don't do that, you'll struggle a lot. You'll have issues. And then let me pass in that variable here called features. Then what I do, let me run and I hope it will work. Let me just pray it works. Let me run. Yeah, guys, it's working finally. Yeah, that's breaking news. It is working. So guys, basically now you can see we have let me zoom out a bit. So guys, let us read the different aspects of the decision tree. And so let's begin with this one. You can say rank is less than or equal to 6.9. So this means that every comedian with a rank of 6.5 or lower will follow basically will follow the true arrow to the left, and that the rest will follow the false arrow to the right. Yeah. And then we also have the Gini here, which is 0.497. This refers to the quality of the split, and it is always a number between 0.0 and 0.5, where 0.0 would mean all of the samples got the same results, and 0.5 will mean that the split is done exactly in the middle. And then guys, we also have samples, which is 13. This means that there are 13 comedians left at this point in the decision, which is all of them, since these are the first step. Then also we have we also have a value which is at least here 6 to 9. This means that these 13 comedians will get a no, and 7 will get a go. So guys, let me talk about this Gini here. So guys, basically there are many ways to split the samples. We use the Gini method in this tutorial, and remember the Gini method uses the formula Gini, which is 1 minus into x over n squared plus the y over n squared, where x is the number of positive answers go, and then x is the number of samples, and y is the number of the negative answers now, which gives us the calculation. Guys, should I show you? Let me just show you the formula. However, you can find it on the website. So Gini, let me zoom in a bit. Gini, the formula is 1 minus into x over n, small n, squared. For squared, guys, let me just use 2 to signify squared. Then a plus into y over n squared. So this is the formula for Gini squared. So this means that this where there's x, that is the number of the positive answers, which means it's go. And then n is the number of the samples, and y is the number of the negative answers, and that is no, which give us the calculation or the result for the Gini. So we can use the decision tree now to predict the new values. Like we can decide, perhaps you can say, should I go to see a show starring a 40 years old perhaps African comedian with 5 years of experience in the comedy ranking of a certain value. Let me show you guys that. And let me show you that. In that case, guys, let me say what in this new cell. In this new cell, let me say what print. And let me say print, and then I'm gonna pass in 1. Remember, 1 means go. Means 1. Then let me say means what? Means go. Means, so here it should be, let me use a double quotes here. Let me use a double quote. Let me remove this one. Then here let me say means. Let me also add in a closing tag, sorry. And then here let me also add in go. Let me say go. And then what I do, let me copy the same. And then let me paste it here. And then here let me give it a 0. Then here no. So let's try this prediction, and then let's try to run and see if it will work. Yeah, guys, basically you can see it is working properly. So guys, basically that's how you can make you can use predict method to predict the new values there. So what will be the answer if the comedy rank was 6? In that case, guys, let me say print let me say print what, d3, and then dot predict, and then I'm gonna pass in a two-dimensional array here, and then first of all is 40, and then 10 and 6. So when they are ranked 6, so basically this means that this person is, the years is 40, and then they have 10 years of experience, and then they have the rank is 6. So what I do, let me try to run and see the prediction there. Let me run, and then wow, there's an error. And let me see what the error. X has 3 features, but a decision classifier is expecting a 4 feature as input as input. So all right, sure. Guys, here I should add, sorry, that's the goodness with this Jupyter for debug. So let me add in 1. Let me add in 1 there, then let me run and see if it will work. Yeah, guys, basically you can see it is 0. It is what? It is a 0 there. So guys, basically you'll see that a decision tree gives you a different results if you run it enough times, even if you feed it with the same data. This is because the decision tree does not give us 100% certain answer. So it is based on the probability of an outcome, and the answer will vary. So if you run it again, you get different whatever different class. So guys, let me now talk about the confusion matrix. So guys, basically this one is a table that is used in classification of problems to assess where the errors in the model were made. So the arrows represent the actual classes the outcome should have been, while the columns represent the prediction we have that we have made. Now using this table, it is easy to see which predictions are wrong and which are right. So first of all, to create a confusion matrix, we can create from a logistic regression. Now, for now, we will generate an actual and a predicted value by utilizing NumPy. So, first of all, let's import what? Let me import NumPy. Remember, guys, you can as well take a break. Like for me, I'm creating this course, but then for you, you can take a break so that you may not congest many things in your brain. You can take breaks and come back later. However, you can pause first of all, and then you'll resume later if you are tired. But then for me, because I'm recording, let me just continue here. So first of all, you import the NumPy. We are using NumPy. And then the next thing, we need to generate the numbers for the actual and the predicted values. So for actual, let me call it actual. Let me call it what? Let me call it actual. Then let me assign it to NumPy dot random, and then dot binomial. It's gonna be binomial. Then I'm gonna assign it to let me give it 1, then 0.9, then the size I'm gonna give it, and the size let me assign it to 1000. Then for prediction, I'm using the same things, the same values, but then I'm just changing the variable so that we may use the one for prediction and then the one for for the actual. Let me here change it to predicted, and then I remember the values remain the way they are so that we may find the the correct results. So guys, in order to create the confusion matrix, we need to import also the metric from the sklearn module. So here at the top, we are going to import from sklearn. We're going to import a matrix, and then now to use it, once the matrix is imported, we can use the confusion matrix function in our actual and the predicted values. So in that case, let's now use it. So let me say confusion. This the spelling for confusion now. I think it has a single S. Then what I do here, let me confusion underscore matrix variable matrix. Let me assign it to this method. Let me say matrix dot confusion underscore matrix. Should be matrix, right? Matrix like that, and then I'm gonna do it. Let me pass in both actual and what predicted. So guys, basically at this point now we need to create a more interpretable visual display. So in that case, we need to convert the table into a confusion matrix display. So in that case, guys, we are gonna do this. Let's do this. Let me add in that code. Let me say cm underscore display basically to create that interpretable visual display. So here let me assign it to, actually let me say dot let me assign but first of all to matrix. Let me assign it to matrix. Then let me say dot confusion matrix display, and then I'm gonna pass in what I'm gonna pass in a confusion matrix. Let me just copy the variable. Let me copy the variable, and then let me pass in here, and then what else? So the next thing now, let me assign it again to again a confusion matrix like that. Then also let me do it. Let me say display underscore labels. Should be labels. I'm gonna give it what display underscore labels. Let me assign it to both false and what false and true values. Oh guys, I'm hoping it works. So hey, let me just hope it works, because repeating these steps is kind of hectic. So guys, basically this is how you can create more interpretable visual display. So the next thing now is to visualize the display. Now to visualize, we need to use matplotlib. So in that case, we need to add here another module called matplotlib.pyplot, but then there's a plt alias. Now guys, once you have imported, then you can display the plot with these functions here at the bottom. Just at the end of this, let me break, and then here let me say what, let me say cm. Remember, this is the variable here at the top there. This cm display, cm underscore this cm underscore display dot plot function to plot, And then to visualize, you're going to say plt dot show. Then let me run and see if it will work. Finally, guys, it is working. Very, very perfect. So, guys, basically you can see how nice it is. So, so basically, guys, this is the results. This is the results here, and basically, let me try to explain now, guys. Basically, the confusion matrix created has created the 4 different quadrants here, and the true negative, that is the top left. Actually, it should be the top the top left, quadrant, that is a true negative, and then the false positive, that is a top right quadrant here, and then the false negative, that is a bottom left quadrant, and then the true positive, that is a bottom right quadrant. So guys, true means that the values were accurately predicted, while the false means that there was an error or the wrong prediction. So guys, basically we have to, now that we have made a confusion matrix, we can calculate the different measures to quantify the quality of the models. So first of all, let's look at the accuracy. Now, basically the matrix provides us with many useful metrics that can help us to evaluate out the classification model. Now, basically the different measures include accuracy, precision, sensitivity, or recall, specificity, and also the F-score. Let me show you that, guys. Let's begin with the accuracy. Accuracy measures how often the model is correct. And how do you calculate the accuracy? That is a true positive plus the true negative over the total prediction. In that case, guys, let me show you that. And the formula, accuracy accuracy is this a spelling for accuracy? Accuracy is gonna be matrix dot accuracy underscore score, and then now you're gonna pass in what actual value, actual, and also the predicted. The predicted, and then what we'll do, let me run and see if it will do what it will. Oh, first of all, guys, I forgot to do it. I forgot to use what to print. So to print, first of all, let me zoom in. Let me say print what you're gonna print it. Print accuracy variable. And let me run again and see the accuracy. And then as you can see, it is 0.834. That is very good accuracy. Remember, accuracy ranges between 0 to 1. So 8 is like a good accuracy. Now let me talk about the precision. And guys, basically of the positive predicted, what percentage is truly positive. So how do we calculate the precision? Now basically it is a true positive over the true positive plus the false positive. Now basically the precision does not evaluate the correctly predicted negative cases. So in that case, guys, let me do it. Let me assign it to precision here. Let me give it a precision. Let me call it precision. Let me call it a precision, and then here I'm gonna change it to precision. Is it so? Precision. And then what I do, let me pass in this variable at the print function. then let me pass in here. Let me pass in here, and then what I do, let me run and see. Oh, guys, sorry, it should be small. Should be. Remember, the variable is what is precision, but then the exact one should be precision, small with small. Then let me run, and then guys, basically you can see it is 0.902. So it's very good. Now, says sensitivity or a recall. Guys, basically of all of the positive cases, what percentage are predicted positive? So basically, sensitivity, or sometimes called a recall, measures how good the model is at predicting the positive values. So this means it looks at the true positive and the false negative, which are positive that have been incorrectly predicted as negative. So how do we calculate it? So we take the true positive over the true positive plus the false negative, and then the sensitivity is good and at understanding how well the model predicts sometimes is something is positive. So in that case, guys, let me change here to recall. Let me call it a recall, and then here let me change it to sensitivity. Let me change it to sensitivity, I think. And then here let me just copy this variable, and then I pass in here the print function, and then let me run and see if it will give us. Yeah, guys, you can see it is 0.91. Now let me talk about the specificity. So how well the model is at predicting the negative results. So basically, specificity is similarly to sensitivity, but then it looks at it from the perspective of negative results. So this one was basically the positive, but then this one specificity it looks at the at the opposite position label. In that case, guys, we are gonna do what? We are gonna pass in we're gonna pass in what another argument here predicted. Then let me add in post label should be label. I'm gonna assign it to, let me assign it to 0. Then what I do, let me run and see and then guys, basically you can see now the results there. Now let me talk about now the F score. Now F score is the harmonic mean of precision and sensitivity. So it considers both false positive and false negative cases, and is good for imbalanced data sets. So basically, how do we calculate it? So it is 2 times into precision times sensitivity over precision plus sensitivity. So this score does not take into consideration the true negative values. So in that case, guys, we're going to change here to, we're going to change it to F1. Let me call it F. Let me call it F1. Then here let me remove this argument here. And then here you can use any variable, like let me use a 1 F1, and then I do what? Let me pass it here, the variable. I don't know if it will work. Yeah, guys, basically you can see it does. So guys, basically that's how you can obtain the F1, the F score. So you can as well, guys, basically get all the calculation in one by printing both the accuracy and all that. But then you can find that example in the website. So guys, let me talk about the hierarchical clustering. So basically, hierarchical clustering is a unsupervised learning method for clustering data points. So the algorithm builds clusters by measuring the similarities between data. And then supervised learning means that a model does not have to be trained, and we do not need a target or a target variable. So this method can be used on any data to visualize and interpret the relationship between individual data points. So here we'll be using hierarchical clustering to group data points and visualize the clusters using both dendrogram and scatter plot. But then how does it work? So guys, basically we will use the agglomerative clustering. That's a type of hierarchical clustering that follows a bottom-up approach. And so we begin by treating each data point as its own cluster. Then we join cluster together, and that have the shortest distance between them, and create large clusters. So this step is repeated until one large cluster is formed containing all the data points. But then this hierarchical clustering requires us to decide on both distance and linkage method. So we'll use Euclidean distance and word linkage method, which attempts to minimize the variance between the clusters. So guys, let me show you an example. Let's start by visualizing some of the data points. Let me first of all zoom in a bit for you to see much better. And then first of all, we are going to import the NumPy. So let me say import NumPy is what is np_alias, and then also let's import matplotlib for visualization. So let me say import matplotlib matplotlib.pyplot, but then is a plt alias plt, and then let's create here a variable, and then I assign it to at least of some integers here. Perhaps let me say 4, 5, 10, 4, 3, 11, and then what is 14, and then what is 14, then 6 perhaps, and then 10, and then what is 12. And then for y, remember the must tally. So here, let me say y. Then let me assign it to the exact number of values. And then here, let me say perhaps 21. Then let me say 19. And then what else? Let me say 24. Then let me say 17. Then what else? Let me say 16. Then let me say 16. Then let me say 25 perhaps. Then also let me say 24. Then what else? Let me say 22. Let me add in 21 and 21. Now let me say what? Let me now use a scatterplot plt dot scatter plt dot scatter. Then I'm gonna pass in the values of x and the values of y. Now to visualize, we're gonna use plt dot show a function. Then what I do, let me run. I hope everything is okay, guys. Finally it works. Yeah, so guys, basically that's how you can visualize some of the data points. So now guys, basically we need to compute the word linkage using the Euclidean distance, and visualize it using the dendrogram. So in that case, guys, let's do this. Let's import these modules here. First of all, let me add in another module here. Let me say we are using some SciPy modules. SciPy, from SciPy dot cluster dot hierarchy, hierarchy we are gonna import what? Let me say import and then dendrogram. Also I'm gonna import the linkage this way. Then now let me create another variable here at the bottom. Let me call it data. And then let me assign it to list. Let me assign it to a list, and then in this list I'm gonna pass in zip, and then let me pass in the values of x and y. And then now to use the linkage here, let's say linkage underscore data is a variable, and then I'm gonna assign it to this linkage method, linkage. Then I'm gonna pass in data. What else we're gonna pass? The method is gonna be method. Let me assign it to what? Let me assign it to word. And then the metric. First of all, comma to separate separate a parameter, and then a metric. I'm gonna assign it to the Euclidean distance. Let me say Euclidean distance there, and then also what else? Let me pass in what? Dendro. There should be dendrogram. I'm gonna give it what? I'm gonna pass in what? A linkage data. This variable. A linkage underscore data, that variable. This one. And then what else? Here we're gonna just say show. Let me say show. Then what I do, let me run and see if it will work. Let me hope it works. So guys, basically I see there's an error here. This hierarchy should be I used a different spelling for this hierarchy. I should have added here R for it to work. Then let me try to run and see if it will work again. And then yeah guys, basically you can see it does. Let me do it. Let me remove first of all this line of code here. And then here guys, let me say what? Let me use a dendrogram. Let me say dendrogram. And then what else? Dendrogram. Then let me pass in what? Let me pass in this. Let me pass in what? Let me pass in this variable here called linkage data. Let me copy. Then let me pass in here. And then what I do, let me run and see if it will work. Let me hope it does. Yeah guys, I basically can see it does. It works. So basically guys, that's how you can plot it. So basically here we do the same thing with the Python scikit learn library. Then visualize on the two-dimensional plot. We can do that. So so instead guys, let me do this. Let me now what I'm gonna do guys, let me import a different module here. Let me say from sklearn. Let me say from what? From sklearn.cluster. Sklearn.cluster. Let's import what? Let's import agglomerative. So agglomerative clustering. And then here guys, I'm gonna change it to the variable is gonna be let me call it a hierarchy. Let me call it a hierarchical. Here should be an R, hierarchical underscore clustering. A hierarchical cluster. Let me just use cluster as a variable, and then I'm gonna pass in what. Let me remove this value so that it may not confuse us at all. Let me just remove, and then what I do, let me assign it to this method. Let me copy, and then I do it. Let me just paste it here as a method, and then what I do, let me pass in. Should be n underscore cluster, n underscore clusters. Let me assign it to 2, and then what is affinity? What I do, let me assign it to Euclidean. Let me call it Euclidean, and then what else? The linkage. Let me copy. So let me say a linkage. A linkage is gonna be what? Let me give it a word. And then the labels. Also for labels, labels is gonna be what? Let me assign it to hierarchical cluster. Let me copy the variable hierarchical cluster, and then what else? Dot fit underscore predict. Fit dot actually predict. Then we're gonna pass in what? Data. Guys, basically this one I think it's just an independent method. What I do, guys, let me cut here. Let me just cut so that I may use it as an independent function here, method. And then here, guys, let me assign it to, basically the label is a variable here. And then I'm gonna pass in what? Data. And then what else? Let me remove this one, and then here let me say what? Let me say plt dot scatter, and then we're gonna pass in the values of x and y, and also the c labels, color labels, labels like that. Then show. Let me run and see. Let me hope everything works. Yeah, guys, I basically can see it works. So guys, basically this is how you can do it. So basically these modules, you first of all need to import the modules for it to work, and then you can learn more about these modules at the Matplotlib course. Remember, I have a full course on that. Then you can also import also the the SciPy. Remember, we used here SciPy. Previously we used SciPy, and then also we used what? We can use which library should we learn about? Yeah, also NumPy. You need to also to have some knowledge of NumPy. Then you need also to create the variables here with the values. And then now, guys, basically this line of code here, this data into list, zip, whatever. Basically, this one turns the data into a set of points. and then guys, basically we need to we compute it with these values here. These are variables. Then to visualize, the first one we use the dentron. Then this one we use the hierarchical underscore class as the variable, and then we obtain the results. So guys, basically find the full explanation on our website, that is Nemtech website. Then you're gonna find everything there, and then guys, basically go to the Nemtech website, then navigate to the machine learning section. But then I want to talk about the logistic regression. Logistic regression aims to solve classification problems. It does this by predicting categorical outcomes, unlike the linear regression that predicts as a continuous outcome. Now, guys, basically in the simplest case, there are two outcomes, which is called binomial. An example of which is predicting if a tumor is malignant or benign. So other cases have more than two outcomes to classify, and in this case it is called a multinomial. A common example for multinomial logistic regression would be predicting the class of iris flower between three different species. So guys, basically here we will be using basic logistic regression to predict a binomial variable, and this means it has only two possible outcomes. So how does it work? So first of all, let me zoom in a bit. First of all, guys, we are going to import NumPy. We're going to use NumPy here. Import NumPy. You see, guys, that the significance of learning this module is very fundamental in machine learning. Even in data science, you need to have these the knowledge of these modules like NumPy, SciPy, Matplotlib, and the other stuffs. So guys, you import first of all the NumPy, then you store the independent variable in X. You're gonna use the X, and then also you're gonna store the dependent variable in the Y. So let me show you an example here, and let me use capital X. Remember, this X will represent the size of the number of a tumor in centimeters. I'm using an example of a malignant, actually of a tumor. And then let me assign it to NumPy dot array. I'm gonna use a NumPy array here, and then I'm gonna pass in a list of the size in centimeters. Perhaps let me say 3.78. The first one. The second one, let me say 2.44. Then the third one, let me say 2.09. And then the other one, let me say 0.14. And then 1.72. 1.72 again here. And then what else? Let me say 1.72. Then here let me use 1.65. And then what else? Let me use 4.92. 4.92, and then 4.37. And then what else? 4.9 what? 96. And then what is 4.52. 4.52, and then 3.69, and then 5.88. And then here also let's extend with this dot reshape. Let me reshape to either -1 or what? +1. And then now guys, basically you need to know that X has to be reshaped into a column from a row for the logistic regression function to work. And then also let's create the Y to represent whether or not the tumor is cancerous or not. So what we do in that case, guys, let me zoom out a bit. Then here for y, I don't know if you can see. Let me zoom in. And then here, guys, let me say what? Let me say y. Then let me assign it to numpy dot array and then I'm gonna pass in a list of 0. Remember guys, a 0 for no, and then a y is gonna be yes. So whenever I put 0 integer, that will mean that is no. So let me say 0 0 0 0 0 0 0. How many zeros are here? 6. These are 6 0. Remember they must tally with the x array, and then also here let me use 1 1 1 1 1 1 1. I think they are okay. Let me show if it will give us the error. We'll just the goodness with the Jupyter notebook, it will give us the bugs. So guys, basically now we need to use the method from the sklearn module. So we'll have to import the module itself. So first of all, here at the top, let's import from sklearn. From sklearn, we are going to import the linear underscore model So guys, basically from the sklearn model, we'll use this logistic regression method to create logistic regression object. And this object has a method called fit that takes the independent and dependent values parameters and feeds the regression object to the data that describe the relationship. So guys, in that case, guys, we are gonna do this. Let me say what? Let me call it log regression. Let me just call it this way. Then let me assign it to linear underscore model. Then I'm gonna assign it not assigning, and then I'm gonna use here logistic regression method regression method. Remember, I have used this logr to represent these are linear underscore model logistic regression. Other than typing that stuffs gonna be hectic. It's a good way always to use variables. And then once you have defined your variable here, then now we have a logistic regression object that is ready to whether a tumor is cancerous based on the tumor size. So guys, basically I want us to predict if the tumor is cancerous where the size is 3.46 millimeter. So in that case, guys, let's use a variable called, let me call it predicted. Predicted. Then let me assign it to log r dot predict. Predict. Then I'm gonna pass in numpy dot array, and then in this array I'm gonna pass in this list 3.46 point, and then we must reshape. Let me say dot reshape to either what? To either -1 or what, or 1 dot 1 or 1, and then what else? But then guys, the other thing, this should be inside this clause, and you shouldn't close it here. It should be here at the end. Also here, where here at the top, guys, here at the top is okay. Then so what I do, guys, here, let me say what is after we have added that, after we have added this variable here, and we have reshaped. So guys, I want us to see the whole sample in action. So in this way, guys, let's try to run and see if it will work. So in that case, guys, we want to print. We are gonna do at print that variable called predicted. And let me hope it works. Wow, there's an error. Let me see what the logistic regression instance is not fitted yet. Call fit with appropriate argument. Oh, guys, I forgot to use that fit here. So in that case, guys, here. In that case, guys, here I must call it. So let me say log. Guys, first of all, once you have used this method, you must also call it log rf, log r. Then let me use a fit. Let me call it user 15. Then I'm gonna pass in capital X and small y. Then let me run and see. I hope it works. It will work. And then guys, basically you can see the result there is 0. So we have predicted that the tumor with a size of 3.46 millimeter will not be cancerous. So guys, basically before we get the example, it is good to know what the parameter we are changing does. So basically, higher values of C tell the model the training data resembles the real world information, and place a greater weight on the training data, while the lower values of C do the opposite. So guys, basically first let's see what kind of results we can generate without a grid search using only the base parameter. So guys, basically first of all, to get started, we must first load the dataset. So guys, basically first of all, guys, we're gonna load in the dataset that we'll be working with. So first of all, let me use here. Let me write new lines of codes here. Let me write here new lines of code, and then here, guys, I'm gonna say from sklearn import datasets. Then here, let me define that datasets. Let me give it a variable of iris. Then let me assign it to a dataset. Dot load underscore iris method. So we'll be using iris instead of this method here. So it will be representing this method. And then now the next thing is to create the module. Basically now, before we create the module, we must have certain independent variables x and dependent variable y. So remember, to create the independent variable, we use this capital X. And let me use capital X. Then let me assign it to iris. Then I'm gonna pass in this string here called data, and then y, the dependent variable, I'm gonna call it. Let me say iris first of all, and then let me pass in what? Let me pass in target. Let me pass in what? Target. And then now we will load the logistic model for classifying the iris flowers. So guys, basically in that case, we're gonna add in this module here. let me say what, let me say from sklearn from sklearn dot linear underscore model import what logistic regression. So guys, basically creating the model, setting max iter to a higher value to ensure that the model finds results. Keep in mind that the default value for C in a logistic regression model is 1. We'll compare this later. So guys, basically I'm going to show you an example of which you are going to look at the iris dataset and try to train a model with the varying values for C in logistic regression. So guys, basically in that case, let's do this. Let me create a variable. Let me call it what? Let me call it logit. And then what I do, let me assign it to logistic regression. Logistic regression. I'm gonna pass in what? Max eta, and then I'm gonna give it, perhaps let me give it even 10,000. Let me give it even 10,000. And now guys, basically after we create the model, we must fit the model to the data. So in that case guys, what we're gonna do, here I'll say print, and then I'm gonna say logit. It is logit dot fit, and then we're gonna pass in that capital X and also Y. Now to evaluate the model, we run the score method. So let me show you that again. I will use the print function, and then here we will say what logit, and then dot score, and then we're gonna pass in capital X, and then Y. So guys, what I do, let me try to run. I think everything is okay. Let me run and see if it will work. Wow, the data set is not defined. Wow. Oh, it should be data sets. Sorry guys, it should be data sets. Remember, if you use the wrong method, it will not work. And then guys, basically you can see it does work. Very awesome. Now guys, basically with the default setting of C to 1, we achieved a score of what? A score of 0.973. Now let's see if we can do if we can do any better by implementing a grid search with that difference values of 0.973. So let me talk about implementing grid search. So guys, I will follow the same steps before, except this time we will set a range of values for C. So knowing which values to set for the search parameters will take a combination of domain knowledge and practice. So since the default value for C is 1, we will set a range of values surrounding it. So in that case guys, what I'm gonna do guys, what did I do here? Let me now define a C. Then I'm gonna assign it to this list. Remember, they must tally. Let me call it 0.25, and then 0.5 perhaps, and then 0.75, 0.75, and then 1, and then 1.25, and then 1.5, and then what is 1.75, 1.75, then finally 2. Yeah, guys, let me say 2, and then here again, guys, I'm gonna use basically we create now we create a for loop to change out the values of C, and evaluate the model with each change. So first of all, guys, let's create an empty list to store the score within. So in that case, guys, let me say scores. Let me use a variable scores, then assign it to an empty list. Let me assign it to an empty list, and then guys, basically to change the values of C, we must loop over the range of values and update the parameter each time. So in that case, let's use our for loop here. Let me say for choice in what? In C. For choice in C. For choice in let me, guys, I just use a capital C. Also here, let me just use capital C. For choice in C. And then let's do this. Let me say log it dot set underscore should be params, and then I'm gonna pass in C choice, and then the other thing is gonna be log it again, log it, and then dot fit, then we're gonna pass in X, capital X, and small Y, and then now the score we are gonna update so that it may go in that empty list. So let me say scores dot append, then we're gonna pass in logit dot score should be score, and then we're gonna pass in capital X, and then what is Y, and then guys, basically with the scores stored in a list, we can evaluate what the best choice of C is by, let me first of all delete this line of code, and then here I'm gonna pass in what? Let me pass in I'm passing what? Scores. Let me believe everything is okay. Let me just believe everything is okay and run and see if it will work. So guys, let's try to explain the results here. We can see that the lower values of C performed worse than the base parameter of 1. But then, however, as we increase the value of C to 1.75, guys, as we increase the values of C to 1.75, the model experienced increased accuracy, accuracy. So it seems that increasing C beyond this amount does not help to increase the model accuracy. So not on the best practice, guys. So guys, basically we scored our logistic regression model by using the same data that was used to train it. If the model corresponds closely to that data, it may not be great at predicting unseen data. So this statistical error is known as overfitting. Now, to avoid being misled by some scores of the training data, we can put aside a portion of our data and use it specifically for the purpose of testing the model. So guys, let me now talk about the categorical data. Now guys, basically when your data has categories represented by strings, it will be difficult to use them to train machine learning models which often only accept numeric data. So instead of ignoring the basically categorical data and excluding the information from our model, you can transform the data so that it can be used in your models. So guys, basically I'm going to use the same data as we used in the multiple regression previously, and I've just renamed the file name, because I have several. I also have that one that we used for, it was what it was I have different values, actually two different files in the desktop. We have data.csv, and then also I've renamed the other one to data_2, but then the values are just not the same, like what we use in the multiple regression part section. So now here guys, let's first of all we are going to use pandas. Let me say import pandas is what is a pd alias, and then let me call it cast perhaps, and then let me assign it to pd, the alias for pandas, pd.read read underscore csv is a csv file. You can as well use the json file. And then I'm gonna pass in it is data underscore 2 dot csv. Remember, it must be csv. If you use a different file name extension, it will not work. And then now here, let me first of all print out and see if it is working. Let me print, and just to confirm, and then let me print what let me print a cast basically to string, cast to string method. Then let me do this, let me run and see if it does work. Yeah guys, I basically can see it is working. So now guys, basically in the multiple regression section, we try to predict the carbon dioxide emission based on the volume of the engine and the weight of the car, but we excluded information about the car brand and model. So guys, basically the information about the car brand and the car model might help us make a better prediction of the carbon dioxide emission. So one hot encoding guys, we cannot make use of the car or a model column in our data since they are not numeric. So a linear relationship between the categorical variable car or a model and a numeric variable, that is carbon dioxide, cannot be determined. Now guys, basically to fix these issues, we must have a numeric representation of the categorical variable. One way to do this is to have a column representing each group in the category. So guys, basically for each column the value will be 1 or a 0, where 1 represent basically 1 will represent what? 1 represent the exclusion. This transformation is called one hot encoding. So you do not have to do this manually. The Python pandas module has a function that is called get_dummies, which does one hot encoding for you. So guys, in that case, let me do this. Let me add in some arguments here. Let me first of all say let me say hey cars, then let me assign it to pd is gonna be pd for the alias for pandas, then get dummies, get underscore underscore what should be dummies, and then I'm gonna do it. Let me pass in a class variable here, and then the two-dimensional array. Then I'm gonna say class. Let me pass in what? Let me pass in car, not really cars. It should be car. Remember, this column is car, not cars. So, and then what you do here I'm gonna change it to this variable. Let me just copy the variable, and then what I do, let me do this, let me paste it here, and then let me try to run. Let me try to run. So guys, basically you can see a column was created for every car brand in the in the column, in the car column. Here let's now create, let me use a capital S, then assign it to pd dot now concat, then we're gonna pass in, these are tuple we're gonna pass in first of all cars, let me say cars, and then also two-dimensional array here, and then here I'm gonna pass in volume. Basically I want to concatenate these ones, volume, and then also the weight, and then after this guys, what we're gonna do here is do this. Let's try to add in, let me use this variable, let me copy, and then guys, also what I'm gonna do here, let me try to add in this argument here, let me call it access, then let me assign it to 1, and then for y, the dependent variable, let me call it y, then let me assign it to cars, then I'm gonna pass in, and that's CO2, carbon dioxide should be CO2, and then we also need guys to import a method from the sklearn to create a linear model. So in that case guys, here at the top, let's do this. Let's let me say from sklearn, we're gonna import what? Import linear model, now we can fit the data into the linear regression. So in that case guys, here let me say this, let me say regre RGRE, actually regret, then let me assign it to here linear underscore model method model, and then a dot linear regression is a method, and then to fit it, we're gonna use these we're gonna add in these parameters here. We're gonna say r regret, and then a dot fit, then we're gonna pass in capital X, and also y, x and y, and then guys, finally we can predict the carbon dioxide emission based on the car weight, volume, and the manufacturer. So in that case guys, let's do this. Let's add in this argument to predict. So let me call it let me zoom out a bit. Let me call it predicted CO2 variable, predicted C, or should be C, or let me call it CO2, then let me assign it to regret that variable regr, and then dot predict, then I'm gonna pass in a two-dimensional array. First of all, it should be inside a tuple, then I'm gonna pass in the two-dimensional array, and then here let me say 2300, and then 2300, and then 1300, and then 0, 0, 0, 0 should be 0, 0, 0, 0, 0, 0, 0, 0, comma 0. Remember they must tally with the number of vehicles here, number of cars, brand. 0, let me change here to 1. I'm not sure if it will work. Then here to the print function, let me say what? Let me print out let me print out predicted what? CO2. Let me say predicted CO2. I'm not sure if let me just run and see if it will work. I'm not sure. Yeah, there's a basically you can see it does 122.45 and whatever. So guys, you can see it does. So now we have a coefficient for the volume, the weight, and the each car brand in the data sets. Let me talk about the dumbifying. It is not necessary to create one column for each group in your category. The information can be retained using one column less than the number of groups you have. For example, you have a column representing colors, and in that column you have two colors, perhaps red and blue. So guys, basically in that case, let me show you guys that example. So that you can first of all, let's import pandas as a PD, and then I'm gonna pass in colors. Then let me assign it to PD dot data frame. Then I'm gonna pass in a dictionary here, and then the first should be colors, and then actually that's the key. Then at the value, perhaps I can pass in a list of colors. Perhaps I can say blue. I said blue, and then at the second color it's red. And then what I do, we print out colors. So let me say print. We are printing what? Colors. We are printing colors. Then let me run and see if it will work. Yeah guys, basically you can see it does. So guys, you can create one column called red where represent the red, and the 0 represent the the not red, which means it is a blue. So to do this, we can create the same function that we used for one hot encoding, get dummies, and then drop one of the columns, and then there's an argument drop first, which allows us to exclude the first column from resulting the table. So guys, basically in that case, let me show you that. Let me add in here another argument. Let me create a variable guys for dummies. Then let me assign it to pd dot get, and then here I'm gonna pass in dummies. Then here let me pass in the colors variable, colors, comma, and then drop. We're gonna use this argument drop to exclude the column, drop underscore first, so that it may drop the first column first, and then let me assign it to true. Then here we are gonna print out our dummies. And then when you run, you can see guys, it's now excluded that column. So guys, basically what if you have more than one groups? So guys, basically how can the multiple group be represented by one lesser column? So let's say guys, perhaps if you have 3 colors in this time, perhaps red, blue, and green. When we get them is while dropping the first column, we get the following tables here. Let me show you guys that. Let me show you guys that. So in that case, guys, let me add in another argument here, another parameter, another list of value. Let me call it blue. Let me call it blue, and then here I'll have to do it. Here I'll have to say, let me say dummies. Then let me pass in what? Let me pass in a color. Let me pass in a color, and then assign it to. And let me assign it to colors. Colors. Then we're gonna pass in what? The color. The color, and then what you do when I run, guys, I basically will see this kind of an output. So guys, basically the other thing that I want us to discuss here is the k-means, and basically k-means is an unsupervised learning method for clustering data points. So the algorithm, it relatively divides data points into k clusters by minimizing the variance in each cluster. So here, guys, I'll show you how to estimate the best value for k using the elbow method. Then I use the k-means clustering to group the data points into clusters. But then how does it work? First, each data point is randomly assigned to one of the k clusters. Then I will compute the centroid, that is functionally the center of each cluster. And then I reassign each data point into the cluster with the closest centroid. Then I will repeat this process until the cluster assignment for each data point are no longer changing. So k-means clustering requires us to select k and then the number of clusters we want to group the data into. The elbow method let us graph the inertia. That's a distance-based metric, and visualize the point at which it starts decreasingly linearly. So basically, this point is referred to as the, and there is a good estimate, a good estimate for the best value for k based on our data. So first of all, let me show you an example. Let me show you first of all how to visualize some of the data points. The same procedures like how you can do it matplotlib, but then let me just show you matplotlib dot matplotlib dot pyplot, but then as a plt alias, then here let me create a variable x, then let me assign it to some values here, a list, perhaps let me say 4, 5, 10. Let me just type in. And then for y, let me say y, then let me assign it to this list. Let me just type in again. And then now to visualize, you're going to use with the scatter, or to plot the scatter plot, you're going to use the plt function, plt.scatter function. And then now you're going to pass in the x and the y, and also to visualize now. Remember the plt.scatter is used to plot, but then now the plt.show is used to visualize. I think by now you understand these stuff. Let me run and see if it will run. Remember, if the values in the x and the y axis do not match, remember the number of values should resemble for it to work. Actually, it should not resemble, but it should have the same values. Actually, the same number of values for it to work. And guys, basically you can see it is now working. But then now guys, basically now we need to utilize the elbow method to visualize the inertia for different values of k. So in that case guys, let me show you this example guys. Let me just show you the example in this new cell. First of all, let me say from you know, sklearn. From SK, let me zoom in guys, I don't think you can see. Sklearn dot cluster should be dot cluster import k means, remember k and m begins with a capital letter. K means, and then what else? So let me now create a variable here. Perhaps let me call it data, and then let me assign it to list into a tuple, and then here let me say zip, and then I'm gonna pass in x and y. Remember the x and y, these are the values here at the top, x and y. And then what I do guys, here let me say first of all guys, it should be enclosed like this. And then what is we need to create an empty list here so that we may add in some our inputs, new inputs. So let me say inertia. Let me call the variables inertias. Then let me assign it to an empty list. And then what is here I'm gonna say, let me use a for loop here. Let me say for I in range. In range, perhaps a range of 1 to 11. 1 to 11. I don't know why it's not, completing, with these rounded brackets when I type in. But then here, let me define k means. Then let me assign it to assignment. We use this equal operator. K means. Then into n underscore cluster, underscore cluster, and then assign it to I. And then what is less? Let me also say k means. Let me call it k means. Then dot fit. Then into, we're gonna pass in data. And then what is let's now do what? Let's now say, let me use this method. First of all, let me say inertia. Inertias, it is inertias, right? Dot append that variable. Append, and then here I'm gonna do what? Let me say k means dot inertia. Dot inertia, then underscore. And I remember always to do it to close like that. So once we are done like this, what I do guys, let me now use the PLT function to add some other stuffs. Like let me say PLT dot dot plot, to plot the original. Let me say to plot this range. To plot the range of it was 1 to 11, 1 and then 11. Then you do it, you close, and then also let's do it. Let me add a comma, then add in inertias, then also marker. I want to use here a marker of that rounded marker, so we use O, and then you do it. Let's close this way, and then now the next one is to let's add in a title. Let me say perhaps a PLT dot title, and then here I'm gonna pass in this let me say elbow method, elbow for the title elbow method, and then I always remember to do it to close. Before anything, this one is a string, so it should be enclosed inside the inside the quotation marks. And then for x label, let's say plt dot x label to label the x-axis. Then here inside here I'm gonna pass in let me say a number of what? Number of clusters. Then you close. And then for y label, plt dot y label. Here I'm gonna say what? Let me say let me label it as an inertia. And then let's do it. Let's close. So I'm hoping everything is okay here. Yeah, I think everything is okay. And then let me try to visualize plt dot show a function to visualize. I think it will work. Otherwise, so guys, basically there's an error here. Here you can see at this line there's an error. So guys, basically here it should be I, not 1. That's the error. It should be I. Not 1. Then you close it. And then what I do, let me reconfirm. Then what I do, let me try to run it again and see if it will work. So guys, also it should be clusters, not clustered the way it is. Then assign it to I. And then what I do, not 1 should be I. Then what I do, let me close. Then let me try to run and see if it will work. Also, k-mean is not defined. So guys, basically it should be means. K-means. It should be k-means. And then let me run again and see if it will work. Also, k-means dot fit. Oh, guys, basically here it should be dot. Should be a dot. Fit. Then into data. I don't know why my notebook is behaving this way. But then let me run again and see if it will work. So guys, basically you can see now it is working, but I don't know why my notebook is misbehaving this way. So guys, let me now talk about the bootstrap aggregation or a bagging. So methods such as decision trees can be prone to overfitting on the training set, which can lead to wrong prediction on the new data. So bootstrap aggregation or a bagging is an ensembling method that attempts to resolve overfitting for classification or regression problems. Now, bagging aims to improve the accuracy and the performance on machine learning algorithms. So it does this by taking random subsets of an original dataset with the replacement and feeds either a classifier for classification or a regressor for regression to each subset. Now, the prediction for each subset are then aggregated through the majority vote for classification or averaging for regression, increasing prediction accuracy. Let me talk about a base classifier in a few. So basically guys, to see how bagging can improve model performance, we must start by evaluating how the base classifier performs on the dataset. If you do not know what the decision tree is, then guys, basically you can review or you can rewind this video so that you may discuss or you may rewatch that part of the decision tree. However, we'll be looking to identify different classes perhaps of wines found in the sklearn wine dataset. So guys, basically in that case, first of all, let's try to do it. This is a new line of code. Let me zoom in first of all, and then here there's a new line of code, guys. Let's first of all import some modules here. So let me say sorry. Here let me say from sklearn sklearn sklearn. Let's do it. Let's import what we are gonna import. We're gonna import datasets. By the way, guys, if you want to see the the auto completion or a suggestion, just place your cursor somewhere where your course is, then click on tab, then it will do it. It will show you some suggestion like for sklearn. When you click on tab, you can see some suggestions there. But then that was just a quick one. But then let me import another module here. So let me say from sklearn again, sklearn.model should be model underscore selection import train underscore test underscore split, and then what else? Let's import also from sklearn.matrix. We are gonna do it. Let's import accuracy score. Accuracy, is this the spelling for accuracy? It should be double C, right? Accuracy score, accuracy underscore score, and then the last one, let me say from sklearn dot tree import what we're gonna import decision is it single A decision tree classifier, and then what else, guys? Basically next we need to load in the data and store it into the X input features in the Y target. So the parameter as underscore frame is set equal to true, so we do not lose the features names when loading the data. So let me do that. First of all, let me create a variable, then assign it to datasets, then dot load, then underscore wine, underscore wine. Then we're gonna pass in what as underscore frame. Oh, my notebook is now restored. I think it's now working well. Sometimes back it was it was hectic. Don't know what was the problem. But then let me assign it to true. Let me assign it to true. Then here let me create some variables like for x. Guys, let me assign it to data dot data, and then for y let me assign it to data dot target. Evaluate our model on the unseen data. We need to split x and y into the train and the test. Now if you want to know more about how to split data, you can go back, you can rewind this video and go back to train test part. So first of all guys, here it is recommended to use a capital X. Let me use a capital X there, and then first of all, now let me split. First of all, let me begin x underscore train underscore train, then also x underscore test, and then y underscore train and then now what else? Y underscore tests underscore test. Then let me assign it to train underscore tests underscore split method split split. Then I'm gonna pass in what? Let me pass in x, capital X, remember, then a y, and then also we are gonna pass in test size, test underscore size, sorry, test underscore size, and then again inside it we are gonna assign it to, let me give it 0.2. Also random state, random underscore state, let me assign it to 22 that way. Now guys, basically with our data prepared, we can now estimate instantiate the base classifier and fit it into the training data. So guys, in that case, what we do, let me say let me call it, let me create a variable, let me make a variable, let me call it d3. Then let me assign it to a decision tree classifier method. Let me copy this class here at the top, and then I do it, let me just paste it here, and then it's a method. So let me pass in random underscore state to 22 that way. And then now guys, basically we now need to predict the class of y, the unseen test set, and evaluate the model performance. So in that case guys, let me create another variable here, basically for y, let me call it y prediction. Then let me assign it to d3, and then dot predict should be predict, and then I'm gonna pass in x, capital X underscore test. Then now here we will print what? I'll print, then into first of all, let me add in some strings there, like let me say train data accuracy, and then first of all, and then also let me add in a comma to add in another parameter here. Let me say accuracy underscore score. Then I'm gonna pass in y, then y. First of all, let me say let me say y true. Let me say y true, and then let me assign it to y. Let me assign it to y underscore train, and then also y underscore pred for prediction. Then also let me assign it to what? Let me assign it to d3 dot predict, and then into what? X train, capital X underscore a train. Underscore train, and then also let's create the other one for test. So let me say print, then I'm gonna pass in, let me say here test data accuracy. Then here first of all, let's separate a parameter, and then here let me pass in accuracy underscore score underscore score, and then let me pass in what? Y true, y underscore true. Then let me also assign it to y test, y underscore test. Then y should be y pred, y underscore pred, and then assign it to y underscore pred, y underscore pred. Then what I do, let me run. I hope everything is okay. Let me run and see if it will work, or if we have errors, it will tell us. So let me run and see and wait and see. And then again, it brings an error. You can see here, this a decision tree classifier instance is not fitted yet. Call fit with appropriate. Call with appropriate arguments before using this estimator. So what I do, guys, let's sort that out. And then what I'm gonna do, guys, let me try to modify that. Where is it? That decision tree. Oh, guys, basically it is true. I forgot to call it. It should be d3 dot fit. And then here I'm gonna pass in. Should be x, capital X underscore train, and also y underscore what should be train also. Let's try again and see if it will work. Alright, it will give us, yeah, guys, basically it is working very, very perfect. Guys, basically you can see the train data accuracy is 1, that is very, very perfect, and then the test data accuracy is 0.8. Remember, when it is around 0.6 and above, that means the accuracy is perfect. You can use it. So guys, basically now that we have the baseline accuracy for the test dataset, we can see how bargain classifier outperforms on a single decision tree classifier. So let me talk about creating a bargain classifier. Guys, basically for bargain we need to set the parameter n estimators, and this is the number of base classifier that our model is going to aggregate together. So basically for this sample data set, the number of estimators is relatively low, and it is often the case that much larger ranges are explored. But then hyperparameter is tuning is usually done with a grid search. I think we talked about that previously, but for now we will use a select set of the values for the number of estimators. So guys, basically let me show that. We start by importing the necessary model. So first of all, here at the top, what I'm gonna do, or let me just use a new cell here. So let's begin, guys, by first importing the module. Remember, once you have this notebook here, once you have imported something here at the top, it will still be the same even if you are in the new cell. But then the goodness with Jupyter Notebook, it just renders the cell data, it is active. When it is blue like this, it is active. And then when you click on escape, that is an active cell. But then when it is blue, it is active. Actually, when it is green, sorry. So first of all, let's import. Let me say from sklearn dot ensemble, right? Import bargain classifier. Bargain classifier. Now let's create a range of values that represent the number of estimators we want to use in each ensemble. So what we do, let me create a variable first of all. Let me call it estimate and estimator. Let me call it estimator underscore range. Then let me assign it to a list. Perhaps let me say 2, and then 4, and then 6, and then 8, and then 10, and then 12, 14, and finally 16. So to see how the bargain classifier performs with the different values of n estimators, we need a way to iterate over the range of values and store the results from each ensemble. To do this, guys, basically we will create a for loop storing the models and our scores in separate lists for later visualizations. But then a quick one, guys, basically the default parameter for the base classifier in Bagging classifier is the decision tree classifier. Therefore, we do not need to set it when instantiating the Bagging model. So in that case, guys, first of all, let me create a model here. Let's create our models. Let me say models. Then let me assign it to an empty list. An empty list. Also scores. Let me also assign it to an empty list. And then let me create now a for loop. Let me say for n estimators. Let me call it n underscore estimators in this range, in this let me copy should be in this range. What I do, let me now create a bargaining classifier here. So let me say, let me first of all scroll up. Then let me say CLF a variable, and then let me assign it to bargaining classifier. Let me copy the class name and I use it as a method here. And then here let me pass in what? Let me pass in what? N estimators. And then what else? Let me assign it again to let me assign it to N estimators. And then also let me pass in random underscore state. Random underscore state. Let me assign it to 22 again. Now to feed the model, let's feed this model, guys, for it to work. So let me call it is a CLF. Remember, if you do not feed, it will not work. And then what you do, let me pass in x train. Remember, we already defined it at the top. So x underscore train also y underscore what? Underscore train. X underscore train and the y underscore train. Now, guys, let's now append the model and the score to their respective lists. In that case, let me use a new line here. Then let me call it a models dot append. Model.append. Then it is a CL what? Should be CLF like that. Then what else? Let's now do it. Let's now append it. Let me say let's append also the score. So let me say scores should be scores dot append, and then we're gonna pass in accuracy underscore score, and then we're gonna pass in y true. Should be y underscore true, and then assign it to y underscore test, also y underscore spread, and I assign it to CLF dot predict method, and then it's gonna be let me use x underscore test. So, guys, basically with the models and the score stored, we can now visualize the improvement of the model. So, guys, basically in that case, we need to import the models here. Let me import again here though we already imported, but then let me just import it here. So let me say import matplotlib dot pyplot is a plt alias p is a plt alias, and then here at the bottom, here at the bottom, let me say what, first of all, let me here say first of all plt dot figure, and then I'm gonna add this parameter here, figure size, figure size. Let me use perhaps 9 to 6, and then to plot it, let me use a plt dot plot. And what are we plotting? We are plotting the estimator range, estimator underscore range, and also versus the scores. Now guys, basically perhaps we can add some labels and a font to make it much more visible. In that case, let's say plt dot x label, then let's say what, let me use n underscore estimators, then let's say font size, adding another parameter called a font size, let me assign it to 18. Font size, let me assign it to 18. Also for y label, let me say y dot, actually plt should be first of all plt dot the model itself, and then y label, then let me assign it to score, a string. Let me say score, and then perhaps let me add in another parameter to increase the, let me say font size. Let me give it what, let me give it this one 18 again, so that they may be uniform. And then now let me add in the last parameter plt dot tick underscore params. I should be params, then let me assign it to label size, let me assign it to 16, and then to visualize the plot, which is plt dot show. Then I hope there's no error. Let me try to run and see if it will work. So guys, basically there's an invalid syntax. It should be assignment. I should have used an assign equal equal operator to assign. Then what I do, let me run and see if it will work. Again, the fixed size is not defined. So I think perhaps there's an error somewhere. So oh yeah, basically I should have assigned it here. You should use an equal operator to assign. I forgot that. Then let me run again and see if it will work. Yeah, guys, basically it is now working. Let me zoom out a bit and see if it is, yeah. So guys, basically you can see it is now very smart. So guys, let me try to explain these results here that you see here. Guys, basically by iterating through different values for the number of estimators, we can see that an increase in the model performance from, it was I think 88 something, but then now you can see it is has now increased to almost 90. This is almost 98 or 96 there. So guys, let me talk about another form of evaluation now. Guys, basically as bootstrapping chooses random subset of observation to create a classifier, there are observations that are left out in the selection process. and that this out of bag observation can then be used to evaluate the model, similarly to that of the test set. But then I keep in mind that the out of bag estimation can overestimate error in a binary classification problems, and that should only be used as a complement to other metrics. So guys, basically we have seen that those are 12 estimators that we used there earlier yielded the highest accuracy. So we'll use that to create our model here. You can see guys, basically it yielded almost 98% accuracy. So we'll use that to create our model, and then at this time setting the parameter to O or B underscore score to true to evaluate the model with out of bag score. So first of all, let's import our modules. There's a new line of code. Let me zoom in, and then here let me say what, let me import some modules here. So let me say from, though we already imported, but then let me suggest, let me zoom in further. So let me say from sklearn imports import what we're gonna import datasets, and then also, by then there's a good practice to have a single cell here at the top, then you import all the modules, and then so that in other cells you don't repeat importing those cells. But then because I'm teaching, let me just show you so that you may know the exact modules that is needed here. And then also let me say from sklearn dot model underscore selection should be selection import train underscore test underscore split and then also let me say from sklearn this is dot ensemble we're gonna import what, let me say import a Bayesian classifier, and let me say Bayesian classifier and then here guys are basically what I do, or guys are basically, should I just use these other codes so that I may not code a lot? Let me just use these codes, guys. Let me just use these codes. So what I'm gonna do here, what I do here, guys? But guys, for you to understand better, let me just repeat myself so that I may not confuse you. And then here, first of all, let's say data, and then let me assign it to what? To datasets. Dot load _1, but then is underscore frame. I'm gonna give it true, and then also let's create a variable for x. Let me assign it to data, and then y, let me assign it to data dot target. Then let's now split our models, basically our data, into train and test. So first of all, x should be underscore train, comma, also x, capital X underscore test, train and test, and then also y underscore train, and then also a y underscore test, and then what you do, let me assign it to train underscore. Let me just copy this class here and I use it as a method here. And then what I do here, guys, let me do what? Let me pass in what? X, capital X, should be capital X, and then also you're gonna pass in Y, and then also you're gonna pass in test size. Test size, let's give it 0 point, let me give it 0.25, and then random underscore state, let me give it what? 22. Then now here instead we're going to use what? These are ob, and then model as a variable. Then I'm gonna assign it to the Bugin class file. Let me copy this class, then I use it as a method here, and then here let me assign it to n underscore estimators, then I assign it to let me give it this time 12, and then here OB score, OOB score, let me assign it to true, and then the random state should be 22 again, random underscore state, let me assign it to 22, and then here at the bottom, let me say what? Let me now call it fit. Let me say o dot model underscore, should be underscore first of all, underscore model that variable, and then let me call it fit, then I pass in what? X underscore train, and also y underscore shall be train, and then now let's print out. Let's say print, and let's print what? OOB model, and then dot OOB underscore, should be underscore what? Then I do what? Let me close. Then what I do, let me run and see if it will work. Let me hope there are no much error. Yeah, guys, basically you can see it is now working very perfect. And then guys, basically since the samples used in OOB and the test set are different, and the data set is relatively small, there is a difference in accuracy, but then it is rare that they would be exactly the same. Again, OOB should be used quick means for estimating error, but it's not the only evaluation metrics. You can see the accuracy there, it is almost 94. So guys, let me talk about the cross validation. And guys, basically when adjusting models, we are aiming to increase overall model performance on unseen data. So hyperparameter tuning can lead to much better performance on test sets. However, optimizing parameters to the test set can lead to information leakage, causing the model to perform worse on unseen data. Now, basically to correct for this, we can perform cross validation. So guys, basically to better understand CV, we will be performing different methods on the iris dataset. So first of all, let us load in and separate the data. So first of all, let me just use in a new cell here at the bottom. Let me zoom in first. Then here at the bottom, guys, let me say from sklearn import datasets, and then here let me say X, capital X, and y, and then let me assign it to what? Let me assign it to datasets. Datasets dot load underscore iris, and then it's gonna return. Let me say return return underscore x underscore y small y to true. Let me now talk about the k-fold. And basically, the training data used in the model is split into a k number of smaller sets to be used to validate the model. Now, basically, the model is then trained on the k -1 folds of the training set. Then the remaining fold is then used as a validation set to evaluate the model. So guys, basically, as we'll be trying to classify different species of iris flower, perhaps we'll need to import a classifier model for this exercise, as we will be using a decision tree classifier. So guys, basically we'll also need to import the CV modules from sklearn. So in that case, guys, also let me do what? Let me import what? Let me say from what? From sklearn. From sklearn.tree. First of all, let's import that a decision tree classifier. Decision tree classifier. Again, also let's import what? From sklearn. sklearn. We're gonna import basically from sklearn model underscore selection underscore selection. We are gonna import what? K should be k-fold. And then also let's import another class called cross for cross validation. Let me say cross underscore val validation score. Then guys, basically with the data loaded, we can now create and fit a model for evaluation. So in that case, guys, let me say what here. Let me call it k underscore fold, and then let me assign it to k fold. Then let me do it. Let me pass in n underscore split. I assign it to 5. Let me give it 5. And then now for scores, let me say scores. Let me assign it to that a class. Let me copy this class name, and then I use it as a method here. And then do what? Let me pass in CLF, and then also let me pass in X. Then let me pass in small y. Then also let me pass in a CV. Assign it to k-folds. Like that. And then also it's a good practice to see how CV performed overall by averaging the scores of all for all folds. So guys, basically what do we do? So what I'm gonna do, guys, let me add in the print function so that we may see these stuffs in the real world. Let me say print. Then I'm gonna pass in a string. Perhaps let me say cross validation, so that we may compare validation score, cross validation scores, and then let's pass in what that variable called scores, and then also let's print another one for. Let me also add in another print function here, so that we will compare. So let me say print, and then here we are gonna pass in is a string. So let me say average CV score. Let me first of all we separate with a comma. Also guys, here I forgot, I should have separated here a parameter with a comma, and then here what I do guys, let me say let's pass in scores dot mean. The mean score should be dot, not comma dot. Should be mean method, and then also let's print out the number of the CV scores used. Let me say a print, then we're gonna pass in a number of should be number of CV scores are used in average, and then let me add in a white space there, then let me separate with a comma, and then let me pass in lane, and then inside it I'm gonna pass in scores. Also here let me add in a white space so that we may separate some, let me run in. I'm hoping everything is okay. Let me run and see. Wow. Cannot import the name decision tree classifier. Oh guys, basically it should be decision class. It has double S here. Also, where else should I change? Let me run again and see if it will work. Yeah guys, also an keyword split type error. Got an unexpected keyword argument. Oh guys, I used a very wrong keyword argument here at the end. Split should be splits, not split. Just where was it? Split should be S. I should have an S here. Then let me run again and see if it will work. Also there's another error, k-fold is not defined. K-folds. Oh guys, basically there's an error there. Should be k_folds. Wow. But then the goodness with this text editor, it shows you the bugs. Also there's another error. Oh, k_fold is not defined. Folds again. Now where is it? Oh, it should be fold, right? Let me just define it here so that sure. Let me just define it there, and then what I do, let me run again and see if it will work. Yeah, finally it's working. Then I guess basically you can see the results there. But then let me talk about the stratified k-fold. So guys, basically in case where classes are imbalanced, we need a way to account for imbalance in both the train and the validation sets. Now to do so guys, basically we can stratify the target classes, meaning that both sets will have an equal proportion of all the the classes. So guys, basically in that way, what I'm gonna do guys, let me do it. Let me perhaps here change it to, let me add in some other parameters here. So guys, basically what I do guys here, let me use what? Let me first of all remember the print function will just remain the way they are. But then here guys, let me just use different arguments here. So here instead, let me use a CLF as a variable, then assign it to this method. Let me copy the class name, and then let me paste it here. Then what I do, let me pass in random underscore state. The same, let's give it 42. Let's give it 42. And then also let's create, let's say what, let me use another variable, sk underscore false, should be false. Then let me assign it to okay, so basically let me use here, instead of k fold, let me use a different one, like I said the stratified fold, but let me just say should be stratified k fold. Then let me just copy this class name. I'm hoping I've copied the correct class name. And then what I do, let me just assign it here. And then what I do, let me pass in n underscore splits. And then what I do, let me assign it again to 5. And then for scores, let me say what, let me create that variable, let me say scores. Let me assign it to this method here. Let me copy that class name, then let me just add that method here. And then here I'm gonna pass in CLF, also capital X, and then y should be y, and also CV. Let me assign it to, this time it is SK fold. Let me just copy this so that I may not type in my thing. So let me assign it to 8. Then what I do is let me run it again and see if it will work. Let me run again. And then guys, basically you can see the results. So guys, basically while the number of folds is the same, the average CV increases from the basic k fold when making sure that it is stratified. So basically this is how you can achieve that. So guys, let me now talk about leave one out, that is LOO. Instead guys, basically instead of selecting the number of splits in the training data set like k fold, leave one out, utilize one observation to validate, and n -1 observation to train. And this method is an exhaustive technique. So even should I show you that? So guys, basically let me just show you that. So in that case guys, I'll just use, sorry guys, let me just do what, instead of what decision tree, let me use this one. And then let me use remove this fold. Let me just remove it. And then guys, basically also to the print function, let me remove what, and that part for, or let it be the way it is, but then I'm gonna replace it with, let me replace with the L, or leave one out, assign it to let me assign it to should be leave one out. Leave one out is a method. And then guys, here I'm going to use LOO. Then what I do guys, let me try to run and see if it will work. Let me run. Leave one out is not defined. Oh guys, basically I should have defined it here at the top. So here I should have said leave one out. Leave one out. Leave one out like that. Then now what you do, let me do this. Let me run again and see if it will work. Yeah guys, basically you can see it does. So basically guys, we can observe that the number of cross validation scores performed is equal to the number of observation in the dataset. So in this case, there are 150, observation in the iris dataset. So the average CV score is this it's 94, times 100, and then yeah. Now guys, basically let me talk about the leave P out, that is LPO, and basically the leave P out is simply nuance difference to the leave one out idea, and then basically in that we can select the number of P to use in our validation set. So guys, let me show you that here guys, I'm going to change it to leave P should be capital what? It should be capital P, then out, P out. Then again here I'm gonna assign it to, let me change it to leave, let me say leave P out. Then here let me change the variable to LPO. Also here I'm gonna pass in what? LPO. And then what I do guys, let me try to run and see if it will work. And then missing one required positional argument, P, leave P out. So guys, I forgot that I should have added here, which is this argument. I ensure that you have this argument here, and then let me give it 2. And then what I do, let me run, and then let me see if it will work. Basically guys, you can see it works, but this one is very exhaustive. As you can see, many more scores being calculated than leave one out. Even with the P, when we assign it to 2, it achieves roughly the same average CV results, you can see. So guys, let me now talk about the shuffle split. Just like unlike the k-fold, shuffle split leaves out a percentage of data not to be used in the train or a validation sets. So guys, basically to do so, we must decide what the train and the test size are, as well as the number of the number of splits. So guys, basically first of all, let me change it here to, should be, let me change it to shuffle, should be shuffle split. And then also we're gonna change in some arguments here. Let me remove this one. Then let me use a shuffle split. Let me use that variable and then assign it to what? This method. Let me copy. And let me copy, and then what I do, let me just paste it here. And then here I'm gonna pass in what? This argument. Let me say train size. Let me give it a what? Let me give it a 0.6, and also test underscore size. Let me give it what? Let me give it a 0.3, and also n underscore splits. Let me assign it to 5. Then here I'm gonna change it to this variable ss. Then what I do, let me run and see the changes there. And then I guess basically you can see it does work, and you can see the CV score has increased. So guys, basically as I wrap up that segment, these are just a few of the CV methods that can be applied to the models. So basically there are many more across validation classes, with the most models having their own class. So guys, let me now talk about the AUC ROC curve. And in classification, there are many different evaluation metrics. The most popular is accuracy, which measures how often the model is correct, and this is a great metric because it is easy to understand, and getting the most correct guesses is often desired. But then there are some cases where you might consider using another evaluation metric. And basically another common metric is AUC, area under the receiver operating characteristics, that is ROC curve. And basically the receiver operating characteristics or ROC curve plots the true positive, that is TP, true positive rates, versus the false positive FP rates at different classification thresholds. And basically the thresholds are different probability cutoffs that separate the two classes in binary classification. And it uses probability to tell us how well a model separates the classes. So let's begin with the imbalanced data. And suppose we have an imbalanced data set where the majority of our data is one value. We can obtain high accuracy for the model by predicting the majority class. So guys, let me just show you that so that talking much is not good for a programmer, right? So here, let me first of all import NumPy. We're going to use this time NumPy. Let me say import NumPy as NP alias, and then also let's import from sklearn. So let me say from sklearn. We are going to import sklearn.metric. Metric should be metrics. We are going to import these classes. First of all, accuracy underscore score. Another class name is confusion matrix. Confusion is this. Does it have double S? Not really. Confusion underscore matrix. Matrix. And then also let's import that ROC underscore AUC underscore score, then ROC underscore curve. And then what I do, let me create some variables here. Let me say n, let me assign it to 1000. Let me assign it to 1000, or a length, let me give it 10,000, and then a ratio, let me assign it to 0.95, or let me just say 0.95. And then notice, let me create another variable here. Let me say n underscore 0. Let me assign it to an integer int, and then here I'm going to say 1 minus that variable called ratio, 1 minus the ratio, and then 1 minus ratio, and then first of all it should be inside this rounded bracket, the parentheses, and then also times n, should be times n, and then also let's create now for n underscore 1. I'm going to assign it to an integer as well. Then I'm going to pass in ratio times n. So now let's create now the y variable here at the bottom. Let me create a y variable, then assign it to np, that is NumPy array. Then in this array I'm going to do it. Let me pass in these are lists here with the 0, and then I multiply. Let me multiply by n underscore 0. Also let me add in let me add in 1. Let me add in 1, an integer, and then times let me say times n underscore 1. So guys, having this, let's now create probabilities obtained from hypothetical model that always predict the majority class. And I remember the probability of predicting class 1 is going to be 1000. So guys, basically in that case, let me use this variables. Let me assign y underscore probability. Let me just say proba, and assign it to a numpy array np dot array, and then I'm gonna do it. Let me pass in 1 times. To multiply, you use this asterisk, and then n underscore 1. We are multiplying with that n underscore 1. And then for prediction, let me use a y underscore pred for should be pred. Then let me assign it to y underscore proba. Then should be greater than let me say 0.5. Now what I do, let's try to do at this print. Let's print f, first of all, f, and then accuracy score, accuracy underscore, and accuracy score, and then notice let me say let me pass in here a dictionary. Then here let me say accuracy underscore score, score. I'm gonna pass in y, also y underscore pred, and then y underscore pred, and then what else should I pass in here? So first of all, after this, let me do that. Let me also create another variable here. First of all, let me remove indentation there, and then let me say cf underscore mat. Then let me assign it to the confusion matrix. Confusion underscore matrix, and then I'm gonna pass in what? Let me pass in y, and also y pred. Let me also pass in what? Y underscore pred. Now once I have this one, this, first of all, let me remove this indentation. Then here what I'm gonna do is let me say first of all, remove this indentation. I don't know why it is coming that way. So let me say first of all, let me say print. First of all, we are going to print confusion matrix. Let me say confusion matrix. This is just a string that is going to appear there at the terminal. Confusion matrix. Then also let's now print out. Let's say print what? We are going to print cf, that variable cf mat, and then also let's print we are going to print what? Let me say f, and then let me say class 0 accuracy, and then what I do, let me pass in this this, let me say cf underscore mat, and then 0, again 0, and then divide by the n over 0, and then what I do, the last one here, let me say what print. First of all, let me do before animation, then I'm going to print, and then I'm going to pass in what, let me say f, and then class of 1 accuracy, class 1 accuracy, class accuracy, and then here let me do what, let me pass in, let me say what, let me say cf underscore mat, then here it will be 1 this time, also 1, and then also let's use 1 again, and then over 1 over n underscore 1, like that. Always remember to add in here the closing of that quote, the quote. Also here let's add in that, and then what we do, let me try to run and see if it will work. Let me run. Oh guys, AOL while scanning string elite for so line 14F. Yeah guys, basically I forgot that I should have added here. Then let me try to run and see if it will work again. So guys, let me run and see if it will work, and then guys, basically you can see it does work. So guys, basically although we obtain higher accuracy here, you can see it is 95%. The model provided no information about the data, so it's not useful. So we accurately predict class 1 100% of the time, while inaccurately predicts class of 0% of the time. The expense accuracy, it might be better to have a model that can somewhat separate the two class. Guys, basically let me show you that. So guys, basically let's do it. Let's have probabilities obtained from hypothetical model that doesn't predict the the mod. So guys, basically in that case, what I'm gonna do, guys, let me do this. Let me just add in these. Let me add in different probabilities here. Let me say what. So guys, basically here, let me add in what? Let me add in this function here. Let me say y underscore proba. This one is going to be 2. Let me use that 2. Alright guys, basically what I do to make things much easier, let me just copy all. Then I use it in a new cell so that it may not interfere. And then here guys, here. And then here guys, what I do here guys, let me say what, let me say y underscore proba. This one is gonna be 2, and then here what I do, let me assign it to a numpy array, np. Basically let me say np dot array. Let me say dot array. Then here what I do is let me pass in what? Let me pass in np dot random. Then it's gonna be a uniform distribution uniform. Then here let me pass in a 0, then 0.7, and then also n underscore 0, n underscore 0, n underscore 0, and then also we are gonna pass in what, another argument here called let me say dot total to basically to list, and then here I'm gonna pass in an empty tuple, then I'm gonna add in, let me say plus plus what, plus np dot random, should be random dot uniform and then here I'm gonna pass in what, I'm gonna pass in 0.3 and also 1, and then here is gonna be n underscore 1, that variable, then also to list underscore 1 to list. Basically, oh sorry, this to list should be at the outside here. Let me cut, and then to list, then what is here here guys, basically let me remove this argument here, and then here pred underscore 2, actually should be 2, and then here I'm gonna assign it to y proba underscore 2. I give it what, 0.5, and then guys, what I do, let me try to run and see if it will work. Let me run. Guys, basically it can only concatenate list but not built-in function or a method to list. So let me check it out. Oh guys, basically I see there's an error here. Sure. What I do guys, let me say basically here it should be this is a method. So what I do, let me run again and see if I'm sure it will work. Yeah guys, basically you can see it does. So guys, basically you can see it works, but then I forgot here to change some here. You can see it here, it should be pred 2 because I will change the variable here. So let me just change it to pred underscore 2. There's no error because we did not delete these other sets, so it does remember that. So guys, basically you can see for this second set of prediction, we do not have as high of an accuracy score as this first one here, but the accuracy for each class is more balanced. Now, using accuracy as an evaluation metric, we will rate the first model higher than the second, even though it doesn't tell us anything about the data. But then in cases like this, guys, using another evaluation metric like AUC would be preferred in that. Let's try that. Guys. First of all, guys, let me use a different cell here. Then first of all, let me say import. Should I import it again, or let me just say diff, because we need to diff. Let me just import. Let me say import matplotlib.pyplot is a plt alias plt, and then here let's now define a function here. Let me say diff, then here let me say plot underscore r or c underscore curve, and then what I do underscore curve, then let me pass in what? Let me pass in true underscore what? Y, also y underscore probe, and then what I do, let me first of all close So guys, let me now add in some plots here which they will be based of the ROC curve probability. So what I do, let me say FPR comma TPR comma thresholds. Then what I do, let me assign it to ROC underscore curve. Then I'm gonna pass in true underscore y, and also y underscore underscore probe. And then let's now have in the PLT function here. So let me say PLT dot we're gonna plot we are gonna plot what FPR also TPR FPR and also TPR. Then notice let's add in the X label. So let me say PLT dot X label. Then here guys, I'm gonna do this. Let me add in this string. Let me say false positive rate. And then for y, let me copy. And then what I do here, let me say change it to let me say y. And then here let me say let me change it to true positive rate. And then guys, basically let's now first of all let me remove the indentation there. Then guys, I want us to run it. First of all, let me say plot underscore ROC underscore score. I'm gonna pass in y and also y underscore probe. And then what I do should be prober. It was prober, right? And then what I do guys, let me print out. Let me say print. Let me say print. And then what we are going to do here, let me say if first of all. Then here let me do this. Let me say model 1 AUC score. And then here let me pass in what ROC underscore AUC underscore what underscore score. Then let me pass in what? Let me pass in y and also y underscore prober. One underscore prober. Then now let's remember to close that quotation mark like that. Then guys, what I do, let me try to run and see if it will work or it will give us the error. So guys, as you can see here, it's not defined here. Then here should be curved, right? I think it should be not really here. Here should be curved. And then what I do, let me run and see if it will work. Yeah guys, I basically have said it does. And basically let me zoom out a bit and so that you may see. And basically guys, it does work. So for module 2 guys, basically for this other one, remember we have two separate values. You have it has plotted these ones, but then now let's try this one, the second the second model. So what I do guys, here I'm gonna change it to sheet should be prober. Let me say prober underscore 2, and then here guys, what I do, let me change here to perhaps guys, let me change here to to 2. So guys, basically you can see it give us the same results there, but then here I forgot, I think I should have changed here to proba 2. Proba 2, let me see where else I should change. I think it's okay. Let me try to run again and see if it will work. Yeah guys, basically this is the score that I wanted, and you can see it is 84, kind of 84%. So guys, basically an AU score of around 0.5 would mean that the model is unable to make a distinction between the two classes, and that the curve would look like a line with a slope of 1. So now an AUC score closer to 1 means that the model has the ability to separate the two classes, and that the curve will come closer to the top left comma here.